Hello everyone. In this tutorial we will be talking about the structural analysis softwares, specifically the CSI ETABS, and we will be going through the software, user interface, the features, and we will going to be making some projects together just to get you used to how to deal with the program. Now get yourself ready, go make yourself a cup of tea or something, and let's start. First thing first is, what is a software that does the structural analysis? Now if you can take a look here, usually this is what we have. Like, let's say this is a simple beam, this is a hinge, this is a roller, and and you have some kind of load, like a distributed load of W in here. In order to calculate the reactions, it's simple. You can get the sigma x, the sigma y, sigma moment, both. Everything is 0. Now, this is because everything is good, right? It's just like determinate structure. Now, what happens when things get a little bit more sophisticated, like this? Now, on here, you have both fixed ends, so it's a bit harder than this to deal with. However, people got around it, and the engineers and mathematicians found a way to solve this, and so forth. Now, this is not the problem. The problem is when you get something like this. You have a frame, and it's, let's say, whatever, it's fixed or hinged in both ends, and now you have multiple stories. And not only in this direction, but you have on the other direction as well. So this is like, let's say this is the elevation, and this is the side, right? And you have your stories as well. So you can't do this. It's really time wasting, and it's really absurd to sit on there, and the only way to calculate something like this is using the matrix, right? So you can't really use any of the other, like the moment distribution or the slope deflection, whatever. You just have to use the matrix for each joint. And if you just, for simple illustration, 1 2 3 4 5 6 7 8, and you have 16 total joints, multiply that by 3, so you get around 48 kind of joints. So you need a 48 by 48 matrix. And for you to solve this, this is going to take time. And not everything is simple. This is just a really handmade kind of sketch. So it's way more than that. It can go up to, let's say, 1,000 point or 6,000 points by 6,000 kind of matrix. So good luck, like really good luck solving that one. That's why they invented the structural analysis programs. Well, what happens is, instead of you doing the calculations, it does it for you. You do the modeling, you do everything on here. It saves you, tons of time. So once you click on the software, this is the first page you're going to see, which is like the welcome page, kind of. Now on here, you'll see the latest notes, which is like the updates for other softwares. They have a whole bunch of softwares for the CSI, the Computers and Structures Institute. Now on here, you have resources and products releases, but that's like not our concern for now. On this side, you'll see the recent models, and you will see the new model and open existing model. So what's the difference between those two? Recent models is basically what you've created on your laptop or on your account, and it shows up here. However, if somebody sent you like a file and you want to access it, you're going to have to use the open existing model and navigate through, let's say, the doc from your desktop or whatever you have saved the file in, and open it this way. Now we're just going to click on new model, and it's just give it a second, and now you have the model initialization, which says use saved user default settings, and we will go through that in a second. It's just basically you have saved your parameters and your inputs, and just you want to keep on using them as your default settings, but we are just starting from scratch, so we haven't really made anything yet. And here is use settings from a model file that you have a pre-saved model already, and you want to use the same parameters and section definitions and material definitions, etc. from that model. Now this is what we're going to be using them for the first time, which is going to be the built-in settings. For display units, I use the metric SI. You can use, which is like meters, kilometers, kilonewtons, Celsius. You can use the US customary, which is like feet, pounds, and I think it's pound force for the instead of kilonewtons, but you get the point. I'm just going to go with the metric SI. For the region default materials, it doesn't really matter. If you live anywhere in here, then it's fine. You can just choose your states. However, we're going to be working with the Egyptian Code of Practice, and it's not featured by the CSI. Unfortunately, it's not featured. Hopefully, it'll be done with the future developments. So for now, these four selections here are not really useful, since we're going to be defining our own. It's just a matter of preference, that's all. So all you have to do is just display units, set it however you want to set it, and then click on OK. It'll take you to this window, which is New Model Quick Templates. Now, if you're familiar with any kind of drawing software, you're going to have a grid, right? You're going to have something to start with. So it gives you the option to first, let's say, the grid dimensions in the plan view, and the story dimensions, which is, this is, as we can say, this is the X. Let me bring this up here, give me a second. There we go. This can be this is like the X direction and the Y direction, and this is going to be the Z direction. So if you can like draw them orthogonally, like let's say it's going to be something like this, right? This is the Y and this is the X. So this is about the Z direction, this is about both X and Y directions. Now it gives you a number of grid lines in the X direction. How many grid lines do you want? This is like 1 2 3 4. So we have 4 grid lines with total of 3 spacing. So spacing. So always the spacing equals to the number of grids minus 1. Now, if we just remove this, now here it tells you the number of grid lines in y direction. It's 4 as well. And then it tells you the spacing between the grids in the x direction, which is 8. So if you can remember, we have 3 spacings, right? And we multiply those by 8, so we have total of 24 meters, as in our grid is 24 meters wide and 24 meters high, since it has also 4 grids in the y direction, spaced 8 meters as well. Now, on the grid labeling options, it's just how you want to name your grids. So the grids at the x direction are going to be like A, B, C, D, etc. from left to right, as you can see here on this radio button. And from the y-axis or the y grids is going to be 1, 2, 3, and so forth. And it's labeled from bottom to top. It can be from top to bottom, depends on how you want to work with it. But I don't really mess up with these stuff, so just keep it this way if you're comfortable with it. Now, if your grid system is more sophisticated than that, it cannot be just defined as a uniform grid, because on here, your grids are going to be a solid number, let's say, but with the same spacing. So it's symmetric and it's a square kind of, or a rectangle. It can be anything different than that. However, if yours is, as I said, more sophisticated than that, then you go to custom grid spacing and click on edit the grid data. Now you see here like the grid system, which is how you want to name it. If you have different grids, as in like an orthogonal grid like this one, or a radial grid, because we're going to be working on radial grids, but not for now. So you can just name it so you know which grid is which. Down here, you're going to see rectangular grids, which gives you 2 radio buttons, as in 2 options: display the grid data as ordinates and display the grid data as spacing. So the difference between those is displaying them as ordinates is technically setting this as your origin point, the 0 and 0 point, and then everything else is relative to it. So the grid A is at the 0, right? The grid B, for instance, is at 8 meters away from the 0, so it's 8 meters from the 0. Grid C is 16 meters from the 0, and grid D is 24 meters from the 0. As we calculated previously, we already know that this is 24 meters wide. It's good in some cases to use the display the grid data as ordinates, but some other cases, I mean the common ones, you get the dimensions of the grids relative to each other. So this is like 7 meters, 5 meters, and 8 meters, right? So, and on larger projects, it's going to be pain in the neck to be sort of like adding everything cumulatively to each other. So what you're going to do is choose display grid data as spacing. What it does here is it's like, okay, I'm going to be more relative. So grid A is 8 meters away from B, B is 8 meters away from C, and C is 8 meters away from D. I really don't know why the origin or the datum is the last one, but it's just the way it is, so it's not really a big deal. So what happens here is, if we can just delete everything, this D is at 0 from itself, so this is the first one. Now it goes 8 meters, then C goes 8 meters, then B goes 8 meters, then A. And if we get to change this, let's say this is going to be 20 meters for just the sake of you noticing the difference. Now this distance from A and B became 20 meters. Now let's get it back to 8. And, yeah, my bad. If you can look here, the same thing for y direction basically. It's just called y direction. And on the bubble size, it just determines the diameter of this bubble with the label of the grid. So in case of, let's say, I have my A on 2 meters, right? And you see that bubbles are just intertwining, they're intersecting each other, so you can decrease this, let's say to 500. I know it's a little bit tiny, but now you can see it better when you're working on your model. But yeah, bubble size is basically just the diameter of the bubble of the label. And that's pretty much it. We're going to click on OK. Now we go to the story dimensions, which is how many stories do you want to have in your project. We said this was the plan, so this is like the roof, right? This is going to be more of the elevation. How high is your building, right? So in this, like, it's a simple story data as well, so it gives you how many numbers, like the number of stories, and the height of the typical story, and the bottom story height, because in most cases, the bottom story height is a bit like larger, or higher, rather say, than the typical story heights for installations. Maybe it's a garage, maybe it's a mall, maybe it's just a fancy entrance, for whatever reason. It's usually, let's say, 5 meters, and the rest is 3, or 4 meters, and the rest of them are 3 meters. So that's why they gave you the option to specify the bottom story height. However, again, as like previously, if you have a more of sophisticated story dimensions, you can just go to edit story data, and on here you can specifically add and change the height of each story. You can also change the name of the story, so instead we can say this is the ground floor, for an instance, right? And you can see here that the height, you can change the height, but you can't change the elevation. What's the difference? The height is more of a relative thing, because he's measuring, my bad, he's measuring the distance between each other. So the distance between the story 4 and story 3 is 3 meters. Between 3 and 2 is 3. Between the 2 and ground is 3, etc. and so forth. However, with the elevation, it's absolute more of kind of measuring, since it measures from the basement or the base floor, and it goes just incremental until it reaches to the story 4. So the 4th story is 12 meters above the ground. Now you can just change this, like let's say for some reason, second floor is not 3 meters, but it's 4 meters. Now you'll see the elevations just adapted and adjusted themselves to the new heights. On this side, you see master story. What does it do basically? Which is you have your building, and now you want to start adding elements into it. You have the stories already, and you want to start adding, let's say, walls, or you want to have an opening that you forgot about making, or you want to add a beam, you want to remove a beam, any kind of changes you have to do. On further projects, let's say we're going to have, let's just close this for a second, let's say we're going to have 16 kind of stories, right? So we have 16 stories. To change a single element in 16 times in 16 different stories is just going to be a complete time wasting process. What happens is you're going to just assign the story 16 to be the master story, and the rest of the stories, the rest of the 15 ones or the 14 ones, are going to be similar to that 16th story. So if I add an element or remove an element from the 16th story, it'll be automatically done to the similar stories. Now, maybe I don't have all the stories similar, right? So I have, let's say, until the 6th story, these are similar to each other, right? Now from the 5th one, no, I want the 5th one to be a master story as well. And the 4th one is going to follow the 5th one, and so forth. Like the first couple of stories are going to follow the 5th one, and let's say this last one is going to be, yeah, let's put it this one. So any change I do for the 16th story will be applied to these guys, right? But not these, because these are following a different leader, let's say. And anything I do to the 5th story will be applied to these guys, and not these. It's just a simple way to put it this way. Ignore the splice for now. Story color is just a visualization way if you have a mega huge project that you want to just differentiate between stories, but it's not. You can like set similar stories with similar colors if you want to. It's just a self kind of preference thing. So yeah. Let's see here what we have. Okay, I guess now we're not going to draw anything actually. Onto here, we're just going through all the options and the buttons to get you to understand what it is, what is it like feature. Now on here you have add structural objects. It gives you the option to start with a blank, so there's no grid, because you might have, you're going to import your grid from, let's say, AutoCAD or from any kind of drawing software, or you have a grid only, which is what we were doing right now, and you have a steel dig, which is he's going to put in a steel dig for you with like the beams, the columns, and the slab, staggered truss, flat slab with parameter beams or marginal beams, waffle slab, or the two-way or ribbed slab. And what's the difference between these two is just a matter of the spacing between the ribs. So you know this can be also called as in hollow block slabs or Hordy slabs. What happens is you have the concrete. Let's just make it a little bit. Yeah, have the concrete kind of a slab, and then you have. Well, I'm gonna make a couple of ribs here. Let's say a rib and a rib, right? And so on. Like we're just gonna cut it through here. So these are the ribs, and this is the hollow block, something like this, right? So the difference between the two ways, or the rib slab or and the waffle slab, is the spacing between the ribs. So the spacing usually with the Hordy slabs is kind of small, can go up to 1 meter, right, or half a meter. I don't think it goes up to 1 meter, just like to say half a meter or 60 centimeter kind of. But with the waffle slab, it can go up to 1.5 meters. So at this point, you can't really put anything here. It's just a void. So it looks like a waffle piece, like literally. And we're going to go into details with that later on. Let's just click on OK. Now you'll see 3 windows: the Model Explorer, the Plan View, Story 16 specifically, at the Z or the elevation of 48 meters, and you'll see here the 3D view. Now you don't need all this, so you can close this tab to give yourself a little bit of space. This is the grid we were talking about. Now, let's start from the beginning. On here, you'll see something called the file, which is in literally every kind of Windows desktop application. So it gives you the option to have a new model, shortcut is Control N, or to open a previous model, shortcut is Control O, and to close the current model, which is Shift Control E. Now you have the save and save as. You're familiar with those, so these are not really new to you. However, the import one, which is going to give you a bunch of options to import a file from a different software with a different extension. Now, this one is probably one of the most important ones, which is the ETABS.e2k text file. Thing is, the version of my ETABS is 21.2, right? Yours might be 22 or 19, so different versions, we cannot directly send the files to each other. What happens is, you're going to export your file as .e2k extension, and I'm going to receive it and import it like as .e2k, so I can be able to run your file on my software. Now, these are like databases from kind of the database, like the database software within Excel, Access, text file, or XML. Now, Rivet structures, if you have a model that's done in Rivet and you want to do the structural analysis, so you just import it to the ETABS. Now, DXF and DWG file of architectural plan, which is, as I said, you don't want to draw your, you're going to draw, or like the architect has already done the project, and he sent you the AutoCAD file with a plan and the elevations and everything. So you're going to create your own structural plan and import it directly to ETABS, so you wouldn't even need to make any grids, and we will go through that in one of the projects. Now, the DXF file of architectural grids, which is basically going to look the same like this, instead of that you just made the grids on the AutoCAD. And DXF file of floor plan, same thing, a 3D model, same thing, but it's just instead of being a Rivet structural model, it's just a DXF model. And these are like a bunch of different softwares that you import your file from, like STAD Pro, and CIS, Steel Detailing Neutral File. It's just, you're not going to be really, you wouldn't really need to be in contact with these guys. Export is basically the same as import, but in reverse. Instead of importing a file, you're exporting the file. And you can see here that it says export story as safe v12.f2k file. And we're going to go through the safe software soon, in a different video, of course, but it's just to make it easier to export the work you have done here to the safe instead of having to redo everything on the other program. Now in here, print graphics and create report. It just creates reports for the details of the project, what you have, how many cross sections, the material used, etc. And on here, capture pictures is just a more specific way of taking a screenshot, if we can say. Project information, comment and logs, you're just not going to really need any of those, for now at least. Now onto the edit menu, if you can look here, you'll see the undo, redo, cut, copy, paste, and delete. These are really straightforward, nothing to say in here. Now I'll skip this one for now. And here you can see edit stories and grid systems. So let's say for some reason you wanted to add a story, remove a story, change the height of a certain story, add a grid, or remove a grid. You're going to click on here, and you'll see this is the story data, and this is the grid system. Modify, and you're back to, you guessed it, you're back to this window again. You can just change and alter anything you want to, and it will be applied right here once you click on refresh the view. Now onto, you just forget on the, like ignore these options. Now the replicate. You can either get it from edit, replicate, or you can click on Control plus R. The replicate window will just pop up. Now what does it do? Technically, I drew my my frame, let's say, it's just, or I drew a beam, rather say, let's just draw a beam real quickly on here, and I want to replicate this beam, right? I want to just copy it multiple times. I'm not going to draw it manually because it will be wasting time, right? So what I'm going to do is I'm going to select my beam, I'm going to go to the incremental data, and I'm going to see, well, I want to move this beam in the opposite direction of the x-axis, right? So the change, the dx, which is the change of the x, is going to be negative because I'm going the opposite direction. And I want to move it, let's say, 8 meters. I want it to be on this side, I want it to be on this side, and this side. So it's 8 meters. My bad, it's 8 meters. How many times you want to, like the number of the replications? I want it to be 1, 2, 3. So 3 times. And I'm going to click, if you hover without clicking, just on apply, you'll see the indications for where the beams are going to be. You click on apply, and there you go, bingo. Now I want to replicate these guys onto the y direction. Same thing, but remember, you have to reselect them, because once you execute command, the selection is going to go away, just in case you don't repeat anything twice. So you select these guys, you go into, okay, now I don't want to move it in x direction, right? I want to move it in the y direction. And I'm moving it along the y direction, so it's going to be positive 8 meters. And how many times do I want to move it? Once, twice. So I'm going to move it 2 times. If you hover onto apply, you'll see the indications. You click on apply, there you go. If we can see here, you can get the 3D view. We're going to go through that soon. We've made it onto the last floor. If we can just extrude the view, there you go. You can see the beams just flying there, enjoying their life, the last floor. This was the linear kind of transition or replication. Now let's go back to the plan view 16. Alrighty. And I want to go on to the radial. Radial is like, you know, kind of self-explanatory. You're just repeating it, as you can see, with a certain angle. Let's say if we can say 60 degrees, and I want 3 of them, so it goes something like this. It's just like pretty much, it's just about a point. And the mirror is basically you're mirroring something along a certain line. Let's say, for instance, this beam. Now I want to mirror it on here, so I want to make it this like this, and then I want to make it like this, right? Instead of drawing it manually, like so, I can do something a bit fancy, right? I can like select my beam, go to mirror, and I want to mirror it between 2 points. I don't know the exact place I want to mirror it, so I'm like, let's say I don't have the coordinates, or I'm too lazy to keep on counting or calculating the coordinates, so I'm just going to click on pick 2 points on model. So I want this is my datum to be mirrored on. So I want it to be mirrored, let's say, along this line. And it automatically puts it, this line is 8 meters from the x, from the 0, from the origin, 24 meters from the origin, and in the second x direction, it's like, about this point is 8 meters from x, and this point as well is 60 meters from the origin, or from y, right? So now, if you hover onto apply, you see it's replicated it. Same thing, I'm going to select my beam, I'm going to click on pick between 2 points, and there you go, and I click on apply, so it did so, and you can just do anything and mirror anything using the mirror replicate. Now, on the story one, as you can see, I drew my beams onto the last floor, which is, that doesn't usually happen, I just forgot to adjust my floor. So I want to now repeat everything on the same floors until I go to the first one. So what I'm going to do is, I'm going to select everything, which is Control A, and I'm going to select, I have already on the story 16, so I'm not going to select the story 16, I'm going to hold on to my button, right, I'm clicking and I'm holding, and I'm dragging down until I get to story 1. Now what you're going to do is, you hover and apply, you see it shows the indication, and once it's done, well, I don't really know what happened, but yeah, it should be, sometimes it's a little wrinkly, but you get the idea. There you go. So you have repeated them on 16 floors, right? All along, all together. Now, if we just remove the extrusion view, so now we have just the center lines or the analysis lines of the beams. This is the replicate in a nutshell. And delete original object is going to replicate everything, but it's going to delete the parent. So I selected this top roof. Let's just show it again. I select these guys, and I replicated it. It will replicate those and delete the first one. And modify show replicate options technically is like, let's go to frames here. I'm replicating this beam, let's say, same cross section, same length, same everything. So I can uncheck this, so it's not gonna, let's say this is an IPE of 400, a steel kind of cross section. And if I uncheck the section properties, it's gonna replicate it, but without the same cross-sectional properties. It's gonna replicate it with a default cross-section property. You wouldn't really need to mess anything on here unless it's a specific kind of once in a blue moon situation that you have to alter something on here. Otherwise, you're not gonna really mess with those. Now onto the next one, which is extrude. You have two options here. Extrude the joints to frames, and then extrude the frames to shells. What does it mean? It's just actually you're changing an element into another element. Not changing it, but you're actually adding an extension to it. For instance, let's draw another beam on here, right? And draw another beam on this side. And I want to like get these two to be like to connect them together, right? So I'm gonna click and select this joint, right? Go to edit, extrude. I want to extrude the joint to frame. I want to extend this joint to be another beam. Okay, now how much do I want to increase, and in which direction? Let's start from the beginning. Let's say I'm gonna go 8 meters along positive 8, so I'm moving to the right, and I click on apply. It goes like this, right? It was extruded 8 meters in this direction. Now I want to extrude it to that direction until it coincides with this beam, so it's like 8 meters in the y direction. So the x direction is 0, and this is 8. And I want to like replicate it once, only once. I want to extrude it one time, not twice. And then I click on apply, and there you go. Wait, let me just show you this error again. It says no selected objects were found to which this edit applies, because as I told you, once a command is executed, the selection is removed. So we have to repeat the selection of this frame. And then I click on apply, and my bad. I click on selecting the joint, and I click on apply, and there you go. If you can look into this, the 3D, and let's hide the grids for now. Let's undo everything. Okay. Now you see this was the joint, and then I want to extrude it 8 meters in the y direction, and there it goes. It's now inside of this beam, right? As you can see. So this is basically the linear extrusion. Let's go back to our plan view, story 1. Now, and let's remove this. Now, when it comes to the radial extrusion, as you can see, it's radial, so it creates a circle, and it revolves your object around the circle, or along the circle. So if you can look here, it says, rotate about a point with x coordinate and y coordinate. So it's asking you which point do you want it to be the center of your extrusion. So the easiest way is just to pick a point from the model. Let's say I'm going to pick this point to rotate around, as you can see now, as you will see in a second. And I want to rotate with an angle of, let's say, 45 degrees, and I want to rotate it like 8 times, and just leave the total drop number of 0. We'll see that in a second. And select your joint. Well, look what happens. If I select this joint, which is the same as the center, and I click on apply, nothing happens. Why? Because I want to rotate the center on top of the center 45 degrees. So technically, it's like, okay, this is your point. This is your point. I'm going to rotate it this time, this time, this time. So it doesn't really change, right? It shows nothing. In order for you to see, you're going to have to select this one and click on apply. Now you see, this is the radial extrusion. Now, if you draw a line, let's just draw a straight line from here to there. This angle right here is 45 degrees. This angle is 45 degrees, and so on. If you change this angle right here, let's say to 90, and let's remove this, select this again, click on apply. Now, the angle between them is 90 degrees in rotation. Now, with the total drop thing is, if you select this joint again, and you want to we're going to repeat it, but at the same time we're going to extrude it radially, 90 degrees angle, and the number of repetitions are going to be 4. The total drop is the distance between the beginning of the extrusion to the end of the extrusion, like the vertical distance, the elevation between them. When it was set to 0, it started from this point, which is the z equal 3 meters, and it ended at this point, which is z is 3 meters. Now let's set this to let's say 2 meters now, and click on apply. Well, you wouldn't see anything right here. Why? Because you can only see whatever is in this plan, which is 3 meters away from the ground. But if we go to the 3D view, there you go. What happened is, as you can see, it didn't go into here. So if we can go a little bit undo and set this to 0, select this joint and click on apply, it started it and ended at the same elevation. Now when we set this to 2 meters, and let's just undo everything, select the same joint, click on apply. Now the difference in the elevations is 2 meters. How can you know? Just right click on this joint to show its properties, go to geometry. Now you see global z is 1 meters, and with this joint, global z is 3 meters. Difference is 2 meters as we've set here. Well, I haven't really used it in any of my projects, but it's just good to know what does this do technically. Now onto the following thing, which is from the edit menu, extrude, and then you see extrude frames to shells. Well, it's the same thing as we did before, but this changes previously we were extruding a joint into a frame, a beam, a column, whatsoever. Now this does, what does it do? It changes the frame, which was the beam or the column, into a shell, which is like a floor, a ceiling, or a retaining wall, a shear wall, or whatsoever. How do we do it? We basically start by drawing our beam. Let's say this is going to be one of our beams, and I'm going to draw one like horizontally, right? And then I come here and I select this one, and I selected one frame, and I want to extrude it to fill this area. So I want this area to be filled with a slab, let's say. So I want to extrude this like 8 meters along the x direction. So I'm going to go here, set this to 0. I want to change the x to be 8 meters. I'm going to do it once, and I click on apply. So you see it drew a slab object. If you right click on here, it's called a slab, right? It's a slab. It's basically an area object. On this one, I want to extrude it upwards, right? So I'm going to go with 0 in x, going to go with 8 meters in Y, or let's say I'm going to do it downwards, so I'm going to go -8 in Y. And I'm going to do it twice because I want to fill all of this area, so I'm going to go twice. And I actually want to delete this beam. I just want to make the floor, like the slab, so I'm going to click on delete the source object, which is the parent object. I'm going to click on apply. So this is what happens. It drew the slabs for me, and it deleted the beam that was originally there. Now let's select everything and delete. Now, if you want to repeat that, but let's say this is going to be 0, and I want to extrude it in the Z direction with 3 meters, so it's going upwards 3 meters. Let's go to 3D view so you can see everything. Let's hide the grids. If I'm going to click on, like, let's set this to 1, I'm going to click on apply. Now you see it deleted the source of the parent object. Let's bring everything back. I don't want to delete the parent object. I just want to keep it this way. It extruded this frame right here into a shell object, an area object. Now it looks red instead of gray because it's vertical. And once it's vertical, the program like automatically thinks it's a retaining wall, a shear wall, or something like that. If it's horizontal, then it's going to be gray. So the software thinks, oh yeah, that's a slab, that's a floor. It's not a shear wall. It's not a core. It's not a retaining wall, and so forth. Now this would be kind of useful if you want to do a staircase, because staircases are usually inclined. So if we get the grids back, right, and I want to go a staircase from this beam up to this little edge right here. What I'm going to do is I'm going to delete this for now. I'm going to select my frame, and I want to go 8 meters, excuse me, in the X direction, and 3 meters in the Z direction. So I'm going to go 8 meters on here, 3 on here. I'm going to click on apply. So now this is how it looks like, right? It's still red because it's not horizontal, but both are like treated the same. It's just a matter for you as a user to tell the difference between a retaining wall and a slab, like, or a floor. And that's pretty much it for the extrude frames to shells. Sorry about that. We still have the radial extrusion. Well, as you guessed it, it's the same thing as we did before, but I still want to show you how it's done. And let's select this guy. It's okay, 1 frame selected. You can see here how many stuff you have selected. So let's say if we do this, you have 2 joints on 1 frame. I'm only like concerned about the frames for now. Let's hide this for now. Okay, now radial extrusion, same thing. I want to extrude around a point, so I'm going to pick my point, which is going to be this, right? And I'm going to go 90 degrees let's go 45, it would look like nicer. 8 times, right? And I'm going to keep the total drop of 0, and I'm going to let's just keep the parent object. I'm going to click on apply. Now see what happened. It drew, if we go to 3D plan, hide the grids, it drew the slab, same thing as you remember, in the previous beam, when we did the radial extrusion, this was the beam, remember? Now this whole thing is covered because we're extruding a frame object, the beam, into a shell of this dimension technically. This little angle, which I'm going to highlight in blue, this little angle is 45 degrees, and it's repeated once, twice, 3, 4, 5, 6, 7, 8 times as we have specified in here. And this is pretty much everything for the extrude frames to shells. Now onto the following thing is merge the joints. Now this is pretty easy. Let's say for some reason you have imported your file, and for whatever reason I have a beam that looks like this, and another beam, let's just get everything back to the normal view, and another beam that looks, let's just keep on zooming in, that is like this, right? You see they're not connected, but if you zoom out, you can't really see. What's going to happen is when you check your model, it's going to tell you that something is wrong, something's unstable. So this is merge the joints. What is going to happen is it's going to basically connect these joints together. So it gives you the merging tolerance. It's like, because you're not going to keep on zooming in on each joint in the model and do that. You're going to click on Control A, and you're going to click on merge. Now, I don't want these two to be merged because they're completely different. So this is what the tolerance has to do. It's like, if the distance is within 1 millimeter or less, it's going to be merged together. If it's more than 1 millimeter, it's not. It's going to be left alone. So let's say if we select those, click on apply. My bad. Click on apply. You see, they're no, because the distance here is more than 1 millimeter. If we increase this to, let's say, 100, and we select those two, click on apply. There you go. It has connected them in one single joint. Now, same thing. If we can go select this one, apply. It's going to tell you no joints were found because he ignored it, because the distance between these two guys is more than 100 millimeters. Now, if we can increase this like just a bunch and select those, click on apply, it connected them together. So it's a really easy way to fix all of your project if there's a discontinuity in your objects or your elements. On to the next thing with the edit menu is align joints, frames, or edges. If you can see here, let's draw our favorite beam. Let's put it here. And the first option is align the joints to the X ordinate, not specifically a joint, but it's just whatever you're selecting in general. So let's say I want this end of the beam to be here, right? So what's the ordinate of this point? It's onto 24 meters, right? And it's onto 3/8, so it's 60 meters. So if you can click on 24, excuse me if I said 23, I'm going to say 24 meters, and I'm going to click on apply. So it went away from along the X-axis, 24 meters. Now, what if I want to shift the whole thing, or I want to move this part? So I just select this little joint and click on apply. It moves. It's away, like it's in the direction of the X-axis with 24 meters, a magnitude of 24 meters. Now, let's say I want to move the whole beam. I'm just going to select the frame itself. I'm going to select the frame. I'm going to click on apply. Now you see it says it says no objects because it needs joints. My bad. So I'm going to select on everything, which is both of the joints. I'm going to click on apply. What happened is instead of moving one joint only by magnitude of 24 meters, I moved both of them by magnitude of 24 meters. Now same thing goes with the y ordinate. Let's select this one, or let's select this one, and I want to move it by 24 in the y direction, so it's going to go up by 24. Now it extended it because it cannot just simply go up there by 24, right? And it's still one beam, like it's the same beam. Now, if I want to do the z ordinate, it's just going to go upwards, but it's kind of really, like if I can show you here, if we can go to the 3D view, and let's remove the grids so you can easily see. Now I want to move this little guy here, I want to get it to the second floor, for some reason, whatever. So I'm at elevation of 3 meters, I want to move it to the second floor, which is at 6 meters, and I click on apply. So it's going to be slanted, as you can see, and we can get the grids back, so it's easier for you to notice. So it's slanted from the first floor to the second one. Now, if I want to move the whole thing, I'm just going to select on both of the joints, click on apply. Now the whole beam is transferred. It's kind of like replicate, but it's just aligning things together, because sometimes you would have a tiny bit of a space between two beams or a beam and a slab, so you want to cover this space, so you're going to use the align command. Now, onto here you'll see align joints to the nearest edge for frame or edge. This is what I was talking about a second ago. Let's go back to story 1, and let's bring our favorite beam back. Right? Let's bring this joint down. So we're gonna go negative 8 meters and click on apply. Oh, my bad. Let's just draw a whole nother beam, and let's go from here, and let's put it this way. Okay. Now, if I have, let's say, another beam right here, and I want to connect these two together. Remember before we went from the edit menu, we went on to extrude, and we extruded it. Now I want to make it an easier way, because I can't really, from the extrusion, I don't know the distance, or I can't really pick the points. What I'm going to do is select this joint, because it's aligning joints to the nearest frame or edge, and I'm going to select my beam, I'm going to click on apply. So it automatically aligns with it. Same thing if it was a slab. So if we drew a slab on here, and I'm going to choose this joint, and I'm going to choose this slab, and I'm clicking apply. So it just dragged it and it aligned, so now they're connected with this point specifically. Now onto the trim, frames, or tendons, or strip objects. Let's say I want to remove these two parts of the beams. So what I'm going to do is I'm going to select the trim command, I'm going to select this joint and this joint, and I'm going to click on apply. Now it's going to remove them until they get to the intersection. Let's say I want to remove it from the other side, so I'm going to select this joint and this joint, click on apply, and it's removed. Now, the extend frame, tendon, or strip objects is kind of similar to align joints. However, it just works with more options like tendons and strips. And what you have to do is just select your joint, select the frame you want to extend to, and click on apply. And there you go. It extended it to that selected frame or beam or whatsoever. Now, on to the following thing, which is move, joints, frames, etc. Now, let's draw, again, our favorite beam. Just put it here. And we want to move this beam to, let's say, this point. I want to move it to this grid right here. So I want to move it 8 meters along the direction of the x-axis. So I'm going to select my beam, got 8 meters, I'm going to click on apply. There you go. Now what if I want to move it to this section right here? So I'm going to move 8 in the x direction, 8 in the y direction. So I'm going to add 8 meters in this direction. I'm going to select my beam, I'm going to click on apply. Now let's say I want to move it some kind of position that I don't know the exact dimensions of it, or the exact distance. I'm just going to click, I want to move this guy from here to, let's say, here. I'm going to click on apply. Oh, my bad, I just select the object. And there you go, it moved it from the point you checked. Maybe you want to move it from this side to, let's say, this side. Select your beam, click on apply, and there it goes. So pretty straightforward. It's not really that hard to get your head around. Now if you can go on to the following thing, which is edit frames, you'll see some of them are grayed out because we haven't selected anything just yet. But let's just draw some kind of a grid system, right? So these are our grids, these are our beams. And now when we go to, let's say, this beam right here, if we can just remove it so you can see the selection, and let's remove the local axis. I'm going to show you everything in just a second. Alrighty, now I select this one, and you see these are 3 different beams. Now I want them to be one beam, so I'm going to go to edit frames, and I'm going to say join them. So now if you select it, it's just one beam along the span, right? Now if I want to break it into 2 beams at the middle, I'm going to go to edit, select the beam, go to edit, and edit frames. Now divide the frame. It'll give you some options. Now it says divide it into 2 objects, so it's going to divide it into 2 equally objects. We can say divide it into 4 objects, and click on apply. Now this is 1, this is 2, 3, and 4. If you can look down here, it says 4 frames, right? And let's undo everything, so it's one beam. And then it says break at intersections with selected frames and joints. So I select these 2 frames, right? So, or let's say, I'm going to select these 2, I'm going to select these 2 joints, and I'm going to break at these joints, so I'm going to click on apply. Now you see I have 1, 2, 3 again. And then it says break at the intersection with the visible grid line, so let's get rid of those. And let's get rid of those. And let's select this guy. Now let's select all of them. Let's join them go to edit frames, go to join frame, so it's one beam. Now let's break it at the intersection with the visible grid line and click on apply. So as well, it breaks it into 3 parts. So this is technically the join and divide frames. Now how about reverse connectivity? Well, this will need a little bit of an introduction first about the directions of the vectors of the beams. So let's say I have my beam, it's in the 2D plan, or 2D plane, it's like this, right? So keep in mind that this direction is X direction, and the direction in plan, if we can do the blue color, is the Y direction, and the direction perpendicular on them is the Z direction, right? So each beam, if we can look at the cross section, which is going to be something like, let me just draw for you, maybe something like this, right? And I'm going to tell you that along, which is the direction that you can't see, or actually we can draw it to be a little bit of a prismatic, so I can say something like this, and something like this, right? So this direction, which is along the beam, is the X direction, and this direction is the Y direction, and let's say this one is the Z direction, right? So what happens is, if I draw the beam from left to right, this is how it's going to be. If I draw it the opposite direction, the X is going to be this way, Y is going to be this way, Z is going to be, if you use the right hand rule and you see X, Y, Z, so it's going to be like, in a different, like we will see in a second, but the connectivity changes. The local axes of this beam changes. So let's go back. And what I'm trying to say here is, if we can just, let's go back and join this to be 1. And let's go to, from here, from set display options, you go to object assignment, and you choose from the frame assignment, you go onto local axes, click on apply. If you go to the 3D, just for quick demonstration, let's hide this, right? You have, in ETABS, they are not called, they don't call them X, Y, Z, they call them 1, let's get a different color, they call it 1, 2, 3, right? Red, green, blue, so it's going to be like 1, 2, 3, as in the RGB colors, red, green, blue, X, Y, and Z, right? In the same order, respectively, of course. So it's always that the X direction is along the center line of the beam. So if you can look here for a second, and if we can set display options and apply, I don't know if it can it's not going to show the extrusion, but if we can see, let's remove the extrusion for a second. This is the X axis, the X direction. This is the Y direction. This is the Z direction. So if we can go back to the extrusion, and we get this. So this is like upwards is the Y direction, and this is the Z direction. If you use the right hand rule, you're going to figure out that your thumb is the X axis, your index finger is the Y axis, and the middle finger is the Z axis. Now what happens when we do, I want to just clear out the numbers, and I want to clear this part, right? What happens if we reverse, and let's, for some reason it probably clicked on undo. Okay, it's one beam now, and then I selected my beam, went to edit, and I went to edit frames, and I clicked on reverse the connectivity. What's going to happen is we don't really see much changing, but if we can go on to here, you see the direction has changed. The X direction is the opposite direction, and the Y direction, Z direction, is in the opposite direction. So technically, previously, that was my beginning, let's say, and that was my end. So this was point I, this is point J. What happened after I clicked on the flip was this became point J, and this became point I. So this became the end of the beam, and this became the start of the beam. So it's really just depends on the direction you draw your beams, and it would facilitate the calculations of the forces, but we're going to check that later on, so it's just to demonstrate what does it do. And last but not least, if we select this little guy over here, and we go into edit frames, modify, you'll see it tells you, if you can just bring it up here, it tells you the story and the label. So the label of this beam is beam 77. It's in the first story. Now the frame type, it's a straight line. However, it can be a circular curve with, let's say the radius is 12, and if you click on refresh the window, now it's going to be a curved beam, as you can see here. Now let's click on OK. Let's click on extrude. Let's just remove this guy, and remove this one. So now it's a curved beam, right? If we can go into edit frames, modify and show, it can be a bunch of different things. It can be a multilinear curve, which you can specify breaking points. So let's say if you click on this one, it's going to go back to a normal beam, because at the start, it's from, let's just bring it to, let's look at it from the plan view to make it easier to see things, right? And let's bring our grid back. Let's remove these guys, we don't need them anymore. Alrighty, so this beam, right, this point is at 0, like 0 on the X, and it's at 16 at the Y, right? So if we select this frame, we go to view, we go to edit frames, modify and show, and we choose to be multilinear. So the start, which became this one, so this is our start now since we reversed. Remember when we reversed the direction of the connectivity? So the start is at 24 meters along the X direction, which is correct, and 60 meters along the Y direction, which is correct. Now, onto the other point, if we click on refresh window on here, so now this point, which is the middle one, IP1, is going to be 12 meters from X, which is 8 meters, and 4 meters, which is 12, and 16 meters from y, which is correct. At the end of the beam, which is this one, it's 0 meters from in the direction of the x-axis, and it's 60 meters in the y direction. However, maybe I want to make it kind of an absurd looking thing. So I'm going to add a new row. So it's broken into 2 pieces now, so I have 3 beams. The first one is at 0. I'm going to leave it this way. However, the second one, I want it to be at 6. So this is the x, this is the distance from here, right? I want it to be at, let's say, 4, and I want it to be at 12. With this one, I want it to be at 8, and I want it to be at 16, that's fine. And for this one, it's fixed because the start and the end are fixed. So if you can click on refresh, you see, this is what happens. You click on OK. If you go to the 3D view, your beam is going to look something like this. I know it's absurd, but it's just because it's just kind of like you're never going to actually use that if you concrete beam. Let's see if it's going to do nothing really happen, but it's just I don't know, you can just like easily draw it yourself. I'm just showing you what does it do. So we wouldn't really, me neither, like none of us would be really using this kind of feature. Now on to the following thing, which is edit shells. It's kind of similar to the edit frames, but it has a bit more options. We're going to draw a slab, and I'm going to also draw a shear wall right here, and I'm going to draw a diagonal shear wall, let's say, right there. Okay, now after I'm done, you'll see that I can select my slab, go to edit, and I'm going to go to edit shells. I can divide my slab into different equal pieces, right? And what you can see here is the local axes that we can set are G, B, X, Y, Z, or you can use the right hand rule, which is this is the X direction, this is the Y direction, which is orthogonal to the screen, and this is the Z direction. Now let's undo the division and select our slab again, go to edit shells. We can merge the shells, so let's say I'm going to redo the division. I'm going to select all these guys, go to edit, and I'm going to merge them together. Now it's telling me, what do you want to merge, right? So I'm in this story, whatever elevation, right? And use the assignments, this area to merge objects, so all of them are going to be F5. And on here is going to display options. It's going to say hide common edges, so you wouldn't see the common edges between them. And then that's pretty much it. All you got to do is these are the selected floors to be merged together, and they are going to be merged into one. Click on OK, and there you go. It's one again. You can see, let's just change this into slab, and yeah, it's back as one piece. Now edit shells, go to expand or shrink the shells. Now let's say this was a little bit smaller than I wanted. I want to expand it, let's say 10 centimeters in each, or let's say 1 meter in each direction. I'm gonna go here, select my whole slab, and I'm gonna say, well, I want to expand it by 1,000 millimeters in each direction. Click on apply, and there you go. 1 meter, 1 meter, 1 meter, and 1 meter. What if my slab was a bit larger than I wanted, and I wanted to shrink it by 1 meter? All I'm gonna do is I'm gonna say negative 1,000 millimeters. Click on apply. Now, if you click on apply again, it goes inside by 1,000 millimeter. And if I keep on clicking on apply, it's gonna shrink by 1 meter from each side. Let's bring it back. Now, let's say I want to extend it or shrink it, but I want to just shrink one side of it. I don't want all of it to be shrinked. I just want this side, for instance. So what I'm gonna do is I'm gonna select these, like this part, right? Only the edge. I'm gonna say I want to offset this guy by 1,000 millimeters to the right. So there you go. It only offset this part. Same can go for this one, and same can go for this one. Like only this one. So you see, it kind of did this weird thing because it has to be connected and continuous. But you get the point, right? Let's get our slab. Let's draw another one so it's solid without those wiggly lines. A little bit better. So you can select the edge by just clicking at the very end of the slab like this, and then expand it how you want. Now onto the second thing, which is from the edit shells as well. It's called chamfer the slab corners. So let's say I'm going to move my slab as we did. So I'm going to call it move. I want to move it 8 meters to the right, 8 meters upwards. So I'm going to 8. I'm going to click on OK. So this is my corner slab. And for some reason, the architectural plan on this part is a curve. It's not like a pointed, sharpy edge. It's a curve. What I'm going to do is I'm going to select the slab with the joint, with this little joint. So it tells you one joint selected, one shell, and 4 edges. I'm going to go into chamfer from the edit menu, go to edit shells and chamfer the slab corners, and I'm going to get this window, and it gives me 2 options: to bevel the edge, which is to have a cut as if I sliced it with a knife. If you can see here, it goes something like this. Or I can say I want to round the edges, and let's say it's going to be 2,000 millimeters, and I click on apply. So it's going to give me this nice little curve, right? And if we can go to the 3D and I remove this, you can see here that it's curved, and if you can even extrude, it's not sharply pointed as this. It's just to be as close or as exact as possible to the architectural plan for the analysis to be accurate as much as we can. Now, if we go to edit shells again, and you can see these 4, it says explode user mesh to shells. Technically, what it does is you have the shell object, and it's modeled as a tiny little shells, right? Tiny little finite elements. That's why it's called finite element method. It breaks this shell into little shells, which is like dx by dy, right? Let's say it's going to be 0.5 meters by 0.5 meters. And it's going to start modeling and getting the straining actions on this shell, on this shell, on this one, until it's done for the whole thing. So what happens is this option right here is going to break your slab into the shells, the tiny shells. So each shell of these is going to be its own slab, which is actually something that you're not going to need because it doesn't, like, it's kind of pointless. Anyways, so yeah, same thing goes for these guys. This is the inverse of it. You merge the shells to create a mesh, and then you remove it, and then you convert the current mesh to a user mesh, which is something we're going to get over later on. Now this one, reverse the wall local axis. So it's technically, if we can show you the local axis of the just one. Alrighty, if I can show you the local axes of the slabs, you can see the red is the x-axis, the yellow is the green is the y-axis, and the blue is the z-axis. If I select this shear wall, go to edit shells, and I reverse it, it's going to get reversed. So this is going to be the beginning, and this is the end. Previously, this was the end, and this was the beginning. Now onto the next one, which is divide the walls for openings. So let's say I want to look at this side, which is the XA, so I'm going to go to elevation, A, I'm going to click on OK. So this is my wall, right? And for some reason, I have an opening here, so I'm going to draw a quick opening, like right here. Now, this is a wall, and this is an opening. But I don't want it to be this way. I want it to be, I want the walls to be separated. What I'm going to do is I'm going to select my shell, go to edit shells, I'm going to say divide the walls for opening. And there you go. Now, this is not an opening anymore. It's just a void. It's not a space you can select. Instead, it broke the shell, your previous wall, into multiple different ones that are around your void, right? Now, on to the last one, which is modify. I'm going to show you, let's go again to our plan view, and let's go to story 1. Okay, let's go to this one. Let's just delete this, and let's delete this. Now, let's go to this one. What's going to happen is, I'm going to go to edit shells, and modify. I can change how this looks like. So instead of being a straight line, I can make it a circular curve. Now looking at these options, it tells me what's the radius. Well, I want it, let's say, to be a curve that this is the center, and the radius is this, which is 8 meters. So the radius is going to be 8 meters, and the center point on the side of the line. Which side is going to be on the left side of the line? So the center point is going to be here, and I want to curve this line into this direction, so into the right direction of the line. So everything's good. I'm going to click on refresh the window, and there we go. This is our little curve. And if you can look at it, my bad, I didn't click OK. It happens so often, so be careful with that. Just make sure to click OK once you're done. This was 8 and everything was right. Okay. If you look at the 3D view, there you go. Let's just remove this for a second. It goes like, it's not an actual curve, because if you can zoom in, you see it's a straight line into a straight. It's just a broken bunch of straight lines making a circle, making a curve. But this is how the way that the software actually uses it for easier analysis, because a circle is basically a polygon with infinite number of edges, if we can put it this way. So if you're going to have a circle, you're going to have an infinite number of edges, so you can have an infinite number of elements to model, which is going to take forever. It's not going to be even done. So it breaks it into small objects that are finite to be modeled. If you didn't get this part, you don't have to worry about it at all. If you can go back to our plan view, story 1, go back on here, let's get our grid back, and from the edit shells, modify. Now you can do a bunch of different things with this one. I just want to show you that this, I want it to curve it the other direction, so I'm going to make the curve on the left side, and I'm going to refresh, so it's going to look like this. So you still have, this is the center of the circle, and I curved it onto the left side of the curve, of the line, excuse me. So this is basically everything you need to know about the edit shells. Now the last thing that we're going to be talking about in the edit menu, which is edit the links. Now what is a link? Let's say for some reason you have a column here, right? And you have a beam, but let's say it starts from there and it goes all the way to here. Again, they're not connected to each other. You can do this in many ways. You can align it to the beam, extend it to the beam, connect them together, but there's a different thing, which is using a link. So you can go to the drawing menu, see this option, it's called draw link, and then you can select this little joint, and you can select the column. Now you see it has a different color because I have set it into to show by properties, but however, let's just bring it back to a normal view. So you see it's a zigzag, like kind of a wavy line. This link connects both the ends of the beam and the column with 6 degrees of freedom motions, the direction X, direction Y, direction Z, rotation of X, Y, and Z. So it restrains the movements of these joints, so as if they are rigidly connected together. Now, if you want to edit this, the only available edit option for links is just reverse the connectivity, which doesn't really matter because a link is just, it's, let's say, a metamorphic way or a hypothetical. It doesn't have a mass, it doesn't have a volume. It's just a way that you're telling the software arbitrarily that these guys are rigidly connected to each other, the column and the beam. And this is everything that you need to know for now within the edit menu. Now on to the next thing, which is the view menu. If you click on it, and we can like just surf and see what each button does. So the first one says set the 3D view. So if you click on it, it's going to give you this little window, and it tells you, well, the fast view, as in which axes do you want to be looking at. So if you can see here, it tells you, do you want to look at the ZX axis, which is this one, or like this one, my bad, or if you want to look at the YZ axis, which is this one, or do you want to look about the XY axis, which is the plan view. So technically, this is the plan view. These are both section elevations, and this is the 3D view. Let's say I want to look at this side of the building, like here. So this one is on the ZX or the XZ, so I'm going to click this one, and then you have to adjust some stuff here. You're going to leave this as it is. Now from the aperture, you're going to decrease it all the way down to 0. So as you can see here, it flattens the image, so it's a 2D image now. Previously, it had a kind of a vanishing point at the center. So let's put it at 60, and let's click on OK. As you can see, now you can still see the slabs, and you can still see the depth of it, right? You can still see those parallel lines going and vanishing into a central point in here. However, if we can go back and set this to 0, this is what's going to happen. You're going to see a 2D dimension of it, right? So this is about to set the 3D view. You can also set the other direction, which is going to look something like this, which is the side of the building. So if we can go back to 3D view, we were looking at this side initially, and then we were looking at this side, right? And then we go here, and you have the XY, which is you're looking from up. If you keep the aperture, you're going to have this, again, a vanishing point at the center where all these perpendicular lines to the screen are vanishing into. However, we don't really deal with that unless you want to look at a behavior or look at the general. You just want to see something specifically with this view. However, you're just going to set it to 0, click OK, and this is what it should look like. But again, when it comes to looking at the 3D, or looking at the plan view, or looking at the elevation view, the set 3D view is just good if you want to look at something that really, as an overall, like you just don't want to look at this section, or you don't want to look at this section like the second one, or you don't want to look at the B section, you want to look at the whole thing as an overall. Now, what we're going to use the most is these two. The set plan view, you're going to click on it, it's going to ask you a bunch of questions. Now, it says a default plan from story level, or like a reference plan, or a specific global Z coordinate. So if we click on this one, and I'm going to tell them, like, if you have, let's say, as you remember, okay, if you have this slab right here, a part of it is neither in the 2nd or the 5th floor, nor the 6th floor, it's in between. So if I click on, you can access it also from here, click on the plan, click on here, and then input the height, the specific height you want to see. Usually you'll be working with this one, and now I want to see the 13th floor. I'm going to click on apply. There you go. And if I want to see the 12th, I'm going to click on apply. There you go. If I want to see the 5th one, click on apply. So it's just the whatever kind of plan you want to look at. Now, elevation is technically the same thing. Let's say I want to look at this height, so I want to look along the A grid. So I'm going to say G1 because I have two kinds of grids on this project. I'm just going to click on apply. So you see, now I only see what's in section A. I don't see the whole building. So this is the difference between the set 3D view as we used it before and the set the elevation view. Now if I want to look at the grid B, which is the following one, looks the same. If we skip a little bit, and this is how it looks like on grid E. Now if I want to look at grid 1, this is how it looks. I want to look at something like grid 6, and this is how it looks, right? Now on here we're going to go through that, but these are like basically the Cartesian grid. If I can show you on, let's go just go to 3D, and right here I have, like, if I select everything and I hide, on here I have a Cartesian grid, right? If we go to plan view, apply, I have this little Cartesian grid for the rounded slab on this side. We're going to go to that like when we are making the project. I'm just showing you how what is everything. Now let's show everything back, and let's go to 3D. Now with the view, if you go down, you're going to see set building view limits. So technically it's like this is the view limit that you have, this rectangle inscribed between those dots. What happens if we move this a little bit like this, and we can click on OK? Now a part of the building will be just removed, right? So anything, and I mean anything, which is taken away, which is like touched the outer parameter, is removed. Now if you want to reverse everything, you're just going to click on show all, click on OK, and everything should be back to normal, except for this little guy, because he's probably just out there for no reason. Let's just let me get rid of him real quick. Alrighty. There we go. Now on to following thing is set display options. Now this is going to be a little bit longer than the other ones. So it's asking you technically, what do you want to see? Well, I want to see, and the first thing you get to see is something called general, and it tells you to view by colors of the objects. So shear walls and any vertical shell is red, columns are blue, and the horizontal slabs are gray. I can set it to section property. So each section, because the column might be 25 centimeters by 60 centimeters, and the other column is 40 centimeters by 80 centimeters. So it's going to show them in two different colors. If we click on apply, it's going to look something like this. Now, they only look this way because all of the columns cross section is the same. They have the same cross section, the slabs as well, and the shear walls, right? Now, if you go to material property, it's probably going to all look the same because they all are made from the same material. Yep, they're made from the same concrete, except nothing actually. All of them are made from the same material. And if you can go into groups, it's just going to show the color by grouping, but I haven't assigned any groups into that. We're going to do that together soon. And the frame design, black and white print colors, then color printer colors, and then stories. So each story would have its own color as you have defined previously from the modified grids, this one, right? So even the last floor is magenta, and there you go. Now we go back to set display options. We're going to set it back to objects and click on apply. Alrighty. Now onto here, you're going to see objects present in view. The joint objects, which is the joints. So technically you have three structural main elements, or three structural ingredients: the joint element, the frame element, and the shell element, right? So it's telling you, I'm going to show you the joints, but I'm going to make it invisible, because if we make it visible, you're going to see those black plus kind of points everywhere, and it's going to make it look kind of crinky. So you just want to put it to invisible again. And for the columns, you just technically set the display of the columns. Now I remove the columns. Beams, I don't have beams on this since it's a flat slab with shear wall, so it's not going to show anything. There you go. And braces, which in the bracing system, if you're working with steel structures, but I don't have any. Now null lines, we're going to go into the elements soon, so it's just, this is the visibility of the objects you have on your project. Now, this is something like, you can just look at these, extrude frames and extrude shells. So instead of looking at the lines of them, because you see now there are a bunch of lines, right? Because technically it draws the analytical model of it. You can say, like, I want to extrude the frames, so any columns and beams, I want them to be extruded, and any shells, I want them to be extruded as well. And there you go. I think there is something wrong with this one, because it should be, but anyways, let's just continue. Now, this also shows some different stuff, as in the restraints and springs of the joints, the diaphragm extent, the connectivity or the connections between the joints. Now, story labels, as if you labeled story 1, 2, 3, etc. and so forth. Dimension lines, as we can see here, if we go to 3D, not 3D, if we go to plan view, if we go to the 13th. So dimension lines, if I click on apply, now you see nothing. So it's a bit cleaner if you're done using the dimensions and you don't need them anymore. Architectural plan layers is the one I told you, you imported from AutoCAD to draw on, and you're done with it, so you can just hide it. And these are the meshing options for the shell. So you can see it should, nothing really happen here, but anyways. Now for the object assignments, you have, as I said, the three ingredients for your structural analysis, which is joints, shells, and frames. Each of them can be defined with a bunch of different unique labels. So the shells have their own labels, as in if we get to 3D plan, right? So this shell, let's say, I want to just right click on it, selecting the column. Okay, this is, it's not assigned to sectional property. Okay, anyways. Let's see if we can select this. Okay, now this is a slab, as we said. Its label you can find somewhere here. Oh my bad, there it is. This is their label, so it's F17, F177. So this is technically what a label is. Unique names is just the definitions of the slabs. It might look a little tiny, so we can tweak that from the option settings later on. The sections, the cross section of each slab. If you can get on here, you can just get everything you need. From here, that's the unique name, the label, the cross-section property, the diaphragm, property modifiers, and so forth. Same thing goes for the frame assignments. The only thing you would actually need to know where it is the local axes, because knowing the local axes of the element would allow you to, oh my bad, because I have it on extrude. Okay, there we go. Knowing the local axes would allow you to know the reactions, the moments about the first axe, second axe, and the third axe. And that's pretty much it. If you want to put back, labels, let me just, there you go. So this was F177. We want to increase the font size. We're going to do that soon. But in the option menu, unique names as well. Click on apply, and there we go. And so forth. Like, just technically, that's what you need to know regarding this one. And these are other assignments, like anything that's not a joint, a frame, or a shell. So what does that mean? Does that mean there are more elements into it? Not really, because these are just like appear as a bunch of shear walls connected together, acting as not one object, like the cores. So cores are technically like this one. The core is a couple of shear walls together acting like one unit. So this is a pier. Now, link assignments, and we saw what a link is and what it does previously on the edit menu. Tendons are more regarding the pre-stressed steel and post-tensioned. Now, support lines, slab panel properties. If you have a waffle slab and it consists of a couple of panels, so you're going to check these slab panel objects, but you're not going to really be in direct contact with these unless you just want to show the labels or the local axes from any of them to know the directions of your element. Now on to the second, the following thing, which is rubber band zoom. Let's just now onto the following thing, which is rubber band zoom view. You're going to technically hold and drag as you're selecting something, but once you release your mouse button, you're going to zoom into that window that you've created. It's really useful if you want to specifically zoom into some kind of point. or some kind of area. So it's a useful feature. Also, the shortcut is F2. It's going to make things way easier for you. Restore the full view. Let's say I did this as well, and then I want to go back to the full view. So I'm going to go to View, Restore the full view, or I'm going to click F3, and it's going to take me back to the original zoomed out view. Now, beneath it says Previous Zoom. So I'm just taking it's like an undo, but for zooming, because you can't just Control Z your way out of it. You have to use the previous zoom. Now, zoom in one step is just going to take you a step ahead. Zoom in, zoom out one step is going to take you a step back. Pan. So panning is like holding your project and moving it along your across your screen. What I like to do, because not each time you want to pan, you're going to go to View and click, or you're going to click on F10. You're not going to do that. You're going to hold. You're going to click on your mouse button, the wheel button, and then you're going to start moving around, right? And as well as walk, which is just you're going to hold on and start as if you're walking on your project, right? So as if you're moving around, you just hold onto your mouse button and then you start moving. And once you're done, and if you click on the wheel button, you're going to start rotating around a pivot, which is like it's in the center here somehow. And once you're done, just click on Escape, and you should be back to normal. There you go. Now let's go and restore the full view. Then the second thing is measure. It's technically a way of measuring lines. So let's say I want to for whatever reason, I want to measure the distance between these two columns. I'm going to go to View, Measure, and I'm going to pick lines. I'm going to pick from this point, and I want it to be to this point. So now on the bottom here, you see the length is 26 feet approximately. And it's going to flash blue for a couple times, but the length is here. It's not going to be gone unless you click on Escape. So it says Plan View, 13th floor, and Z with 144 feet. Now go to Edit. Go to View, my bad, and go to Measure. Then measure the angle. So we can just measure the some kind of angle, like let's say this, right? So it gives me the measurement of the included angle between them, which is 43.12 degrees. And if we go to View, last but not least from the measure is the area. And now you just want to measure the included area between these four columns. And if you can't really snap it back to close it, you can just right click anywhere and it's going to just continue the shape. Now it tells you that the area is 581.4 approximately feet squared, and the parameter is 96.5 feet. So it gives you both the area and the parameter. Now, if we can go back to 3D view, and what you can do is, what I was doing previously on the edit menu is hiding the grid, because sometimes it can get in the way. So to do that, you're going to set the grid visibility system. And since I have two different grids on this project, it will always ask me, which grid do you want? Do you want it to be visible or invisible? In this case, I'm going to make both my grids. Just double click on it, or click, and then click this the arrow to switch it between the tabs, and click on Apply. Now it's going to be gone. And I want to just bring back, let's say, only the Cartesian grid, the circular or the polar grid. And I'm going to click on Apply. And there you go. I can only see my circular grid, my radial grid. And so as well, if I want to just show the orthogonal grid, I'm going to click on Apply. I'm going to be able to see only the orthogonal grid, but not the radial one. Also, easy way to do it if you have one grid only is Control D, because down here is going to ask you always which one do you want to show and which one do you want to hide. But usually, let's just show everything. When you have only one grid, Control D is going to do it automatically for you. It's going to hide it for you, and then it's going to show it again for you if you want to. And now the local axes, technically it's just like a toggle on and off button to show you the little local axes we have down here, X, Y, and Z. And then they change the position of the local axes, which is I'm going to say I want to move this, let's say 100 feet in the opposite direction of the x-axis. I'm going to click on OK, and it's going to be like something here. There you go. It's shifted. And to bring it back, unfortunately, you can't Control Z your way out of it, so you have to go back here and click on 0, click on OK, and there you go. It's back to its original position. Now, again, if you go down here, it says show selected objects only. So, for instance, if I select these guys right here, go to View, Show Selected Objects Only, it's going to hide everything else except for the selection. So there it goes. And then go to View and then invert the visibility of the objects, which is going to hide these guys that you want looking at right now and show the others. You can click on it, and there you go. The columns and the slabs on this section are removed. Now the others are like out there. Go to View and then make selection objects invisible. It's technically the opposite. If you just select these guys and go to View, make them invisible, it's going to hide them. My bad. Let me select these. View, make them invisible. There we go. It removed the objects that were selected. And then restore the visibility of the previous selection. It's just going to restore the stuff that you have previously made invisible, only the selected objects, not everything. And to restore everything, you're going to see here, show all objects. And there we go. Everything should be back visible on the project. And refresh window is if you have changed anything, but you can't really see on your project, and you know that you've done it properly, you can click on View and refresh the window to refresh everything. Let's say you have a different view here. Let's add another view. And let's make this a plan view of the 3rd floor. And let's get this to be our 3D view. Right, so now by refreshing the window, it's going to refresh both of them. However, by refreshing the view, it's just going to refresh this one and not this one. So yeah, you just know it. Now show the rendered or ray tracing. Well, this is gonna actually give you like a fancy photo. Not really fancy because the ETABS would take ages to do the rendering, and it's not as good as the other BIM modeling software that is intended for visual representation instead of structural analysis. So it's just gonna start rendering your picture. And if I just like quickly demonstrate you, and you can, if you have a good kind of GPU, you can use the parallel processing, so it's kind of faster. Let's remove the diffuse and let's just start rendering. So as you can see here, it's drawing the picture, let's say, right? And once it's done, you have a picture as if you've taken it in real life, except it wouldn't really look like it's been taken in real life. It's just a good thing to have, right? But you wouldn't really use it, since you would use the other drawing software for rendering and visualizing your project. Let's just cancel because. And then last but not least, in the view menu, you have the DirectX view settings. Yeah, just don't mess with this because it's related to your RAM, VRAM, your GPU, and your processor. So just leave it this way. The software would know what's best for your specs on your laptop or your desktop PC, and that's pretty much it for the view menu. Now we will be talking about the define menu, and once you click on it, it's going to tell you what do you want to define. Basically, you start putting in the parameters of the materials, the cross sections, whatever you're using in your project, and a bunch of different things we're going to go through. So first thing is the material property. Now, since, as you can, if you remember previously when we were choosing the built-in settings, the metric, the display units, and the codes of construction, etc., we settled on the American, the ACI. So that's why the materials, which is the reinforcement, and the concrete are called like this. If we chose another, like let's say the Euro code or the British standard, it's going to be named differently. So if you want to edit, because of course you're going to edit your material property, so you can click on modify, or you can double click on the material. Now, material name, I'm going to go with C as in concrete 30, and it's concrete isotropic. The color, you can just leave everything the way it is. Now, for the weight per unit volume, we're familiar with that the concrete is 25 kilonewtons per meter cube, right? And it automatically calculates it as a mass. Now, the modulus of elasticity, it differs from a country to another according to what code they're working with. So, since we said we're going to be highlighting the Egyptian code of practice, so the modulus of elasticity of the concrete is 4,400 multiplied by square root of 30. So you don't have to do this on a separate calculator. You can do it on here, and it's going to calculate itself. To do the square root, you're going to basically say 30 raised to the power of half. Click on enter, so it's going to be 24,099. Stay like almost 24,100 megapascals. Now, for the Poisson's ratio, you can leave it this way. Technically, the Poisson's ratio is, if we can like demonstrate it like real quick right here. And okay, so you have the object. Let's say you have this little square right here, and you're applying pressure like this, right? So the dimensions are not going to stay the same. It's going to shrink a little bit, right? However, on the outer sides, they're going to expand a little bit. So if you can do that in green, so it's going to expand a little bit. So the Poisson's ratio is literally like the ratio between the transverse and the lateral kind of deformations. Just like this is for quick demonstration. You don't really have to bother yourself with. You can just leave it at 0.2, and the coefficient of thermal expansion, you can just leave it the way it is, unless you know, or the code specifications state something else. Shear modulus of the shear modulus is going to be predefined already according to the modulus of elasticity. And onto here it says design property data. If you click on it, it's going to tell you material name, material type is concrete, and it's isotropic, and then the grade. So you can see here it says F prime C. It's not FCU, it's F prime C. The difference is, in the United States, or whatever uses the ACI, they do the tests like the cube test that we do on the concrete cubes. They don't do cubes, they do cylinders. So the F prime is the maximum allowable strength for the cylinder. So we can just remove everything on here, right? And then we can say C30. And technically it's 80%, so you can say 0.8 multiplied by the FCU of the concrete you have, so it's going to be 24 for this one. Lightweight concrete is used for some certain purposes, as in, let's say, floating bays or isolations, but we're not going to really use that for now. So you're going to click on OK. Now, advanced material property data, you're not going to be really, you don't want to mess with that currently. We're going to go through everything, but later on, and then you click on OK. So now we've defined your concrete. Now, when you're done with defining your concrete, you want to start defining your steel property. So double click on it. Go here and adjust it to be, let's say, F yield of 420 megapascals. And down here, you're going to see steel, isotropic, color. You can change it, you can leave it. And then material notes, as in if you want to write anything for your colleagues to, if you just want to say something about the steel. Now, the unit weight or the gamma of the steel is 78. Modulus of elasticity is 200,000. Poisson's ratio is 0.3, leave it as it is. And the coefficient of thermal expansion, just leave it as it is, if not stated otherwise. And the shear modulus is going to be automatically predefined once you define the modulus of elasticity. Now, when you go to design properties, click on this one, and you can also change the name of this one to be F yield 420. Now, for the minimum yielding strength, which is the grade, it's just going to be 420 megapascals. The minimum tensile strength, and to take a look at it, you can say that, okay, there's something called ductility. Excuse me. of the steel. Technically, the ductility is the ratio of the F ultimate divided by the F yield. And regarding Egypt, it's going to be 1.5. So our ratio is going to be 1.5 times the F yield, which is 420, so it's 630. Now the expected yield strength is 10% more than the minimum yield strength, so you're going to say 420. And the effective tensile strength is 1.1 as well. Like the expected and the effective are kind of the same thing, and it's 10% more than the ultimate. And that's it. Now you've defined your steel property. Now, after the next thing is the section properties, and you'll see here first thing says the frame section, and we know already that frame sections in ETABS is beams, columns, and spandrels, if we can say. So technically, you're going to see here, which is a bunch of predefined elements, right? You can delete multiple, which is that those that are not used. You cannot delete an object or a frame that is already used. Now we can't delete this one because we have 4 columns on here defined by the concrete column. And what you want to do is you can either import new property from a file that you have on your desktop, or you can add new one. And then it's going to give you a bunch of different options. What's your section type? Is it concrete, rectangular, steel, angled, whatever? But easier way is just to choose it from here. So this is a prismatic kind of shape. So it's a rectangular concrete, circular, and the T section and a precast concrete. This is for steel. This is for composition, the composite kind of elements. And these are special as in non-prismatic, that like it goes, let's say you have a column that is like something like you have like a frame, and your column is something like this. So the cross section of the column on here is different from this point. So this is a non-prismatic, right? So it's also like, there it is. Now onto, let's say just we're gonna choose our concrete. Gonna give it a second to load, and then we're gonna name it. The way you name it is the dimension. So this is gonna be a beam, so you're gonna say B, and we're gonna call the depth, which is this one, let's say it's gonna be 25 centimeters, multiplied by the breadth, which is gonna be 25 centimeters, multiplied by, let's say, the height, which is gonna be, or the depth, which is gonna be 60 centimeters, or the overall thickness of the beam. Now you can leave like the material just as we did it before, C30, but I didn't really save it, and go down here and you'll see the depth. So the depth is 600 millimeters. Just notice the difference between the units. Now we're using centimeters on here, we're using millimeters on this one, and the width of it is 250. Right? Once you're done with this, you can go to property modifiers if you want to, if you want to decrease some of the sectional properties, because some codes would require you to decrease the, let's say, moment inertia about the 2 axes, so the moment of inertia in around the y direction, let's say, and the moment of inertia around the x direction. Also the torsional constant, so it's going to be reduced, so some of these stuff will be reduced due to the cracking of the concrete. Now for the reinforcement, you're going to click on it, and it's going to ask you a bunch of stuff. The design type. Is it regarding normal, moment about 2, moment about 3, as in column? Nah, it's a beam, so it's just a moment about the 3, a moment around the angle number 3. And the longitudinal bars is whatever bars you have predefined. Now the cover to the longitudinal rebar group centroid. Now, and on here we're going to have to say something real quick, right? So let's just get back on the screen. Now this is, let me draw, okay, so something like this. This is our cross section, right? And my steel, let's just get a kind of smaller one. Okay, so this is my rebar, 1, or let's get it something like this, 2, 3, 4, and I'm just gonna say 5. And then I have my tie, which is the confinement, sorry about that, which is gonna be something like this, right? And it goes all the way up, and it just goes around, and it goes all the way down. And on this top you have like the, you're gonna have the hangers, which is just like, you know, from 10% to 20% of the main area steel. This is the area of the steel. Now, what happens is they have 2 different kind of covers. You have the clear cover, which is from this face, like just the beginning of the tie until the end of the beam. So this is a clear cover. And then you have the cover from the centroid of the steel to the end of the beam. So this is just the cover. So the difference is this one is about 25 millimeters, right? This is just a bunch of concrete down there. Now, when you add the centroid, you're adding the diameter of the tie, and let's say we're using 5, 5, 10 per meter one. So the diameter is 10 millimeters, right? So 25 plus 10. And you add also half of the diameter or the radius of the rebar. Let's say we're using 5 bars and they are 520, right? So they're going to be half of the 20, so it's 20 over 2. So you're going to end up with about 45 millimeters in the cover, so you can approximate that to 50 millimeters, right? Now, if you have more than one row of reinforcement, something like this, something like that. So now you're going to have another beam, another reinforcement bar like this, right, to just put these reinforcement bars on top of. And what's going to happen is when you start getting the centroid, now you don't know where is the centroid because it's not here and it's not here anymore, right? What happens is, let me just clear this a little bit and clear these, right? Just clear everything. What happens is the centroid shifts to the centroid of all these rebars together, which is going to be something like in the middle. So your cover is going to be from the middle centroid until here. So it's going to be this little concrete cover, which is 25, plus the diameter of the tie or the confinement, which is going to be 10 millimeters, plus the diameter of this one, or you can just say this distance, which is the diameter of the lower rebars, which is 25, plus half of the diameter of the, let's say, the splicing or like the splitting bar, which is going to be, let's say, if we use a bar of 20 millimeters diameter, we're going to say something like 10. So you're going to end up with 70 centimeters as in the cover. So this is the clear cover in a nutshell. The difference between the clear cover and the normal cover. So now it's asking from the group centroid, we're going to just say 50 and 50. And that's pretty much it. Just ignore this. So now you're going to see that the rebar has been removed, and you're going to, oh yeah, before you leave, the newer versions of ETABS, it has include automatic rigid zone over the column. Because sometimes, as we have said, the connection between the column and the beam is not, like there is a tiny gap between them. So what happens is, if we look into the plan view, I'm just going to click on OK for now, and I'm going to get to the plan view. I'm going to get to story number 2, right? And let's do, yeah. So what happens when I include the automatic rigid zone and have a beam like here, right? The area on top of this column, this area, is going to be defined as a very rigid area. So anything that comes in touch with it, it doesn't have to be connected from center line to center line, because like it doesn't have to be like this, right? If it's just inside the zone, if it's within the rigid zone, it's going to be included as a fixation between them. So this is a new feature in the newer versions. And if you can see here, go back to sectional properties, and we go back to modify. Well, I can't really see it, but anyways, add new, concrete, whatever. So if you check that, then you must like have some issues with the connections due to whatever the architectural plan or whatsoever. I personally don't like it. I like to either use a link or to just try to align everything perfectly so it doesn't need to create this automatic rigid zone on the column head. Next thing is define section property tendon sections. Now tendons are the wires or the steel cables that are used for pre-stressing the concrete, right? And it's not really that hard. You're just going to click on modify right here, and you're going to name it however you want to name it, and choose the material type for the tendons, and the strand area, which is like the area, the cross-sectional area of the strand or the wire of the tendons. That's pretty much it for the tendon property. Now from the section properties, you're going to see slab section. Now this is the slab, and these are the sections. Now there's just, you're going to start adding your own, so add new property, and let's name it however the slab is. So let's start with a solid slab, right? And you can also add the thickness, which is, let's say, going to be 120 millimeters. With the material, we can see the concrete, right, that we define for C30, and then modern type is shell thin, and the difference between those is shell thin is like the normal slab. It can resist the moment or the flexural moment. Shell thick is more of like things that are above the thickness of half a meter or even a meter, which is the mat foundations. Membranes are the shell elements, let's say, that only resist the axial force. Now, if we can just go real quick right here and explain. So if you have, let's say, a dome, right? So the dome is going to be something like this. And just excuse my forward drawing right now. And the dome is subjected to its weight, right? And since the shape of the dome is the invert of the bending moment, right? So it actually converts the flexure into pure bending, compression, my bad. So this is a membrane. A membrane does not really withstand a flexure force, a flexure bending moment. It withstands a compression kind of bending, compression kind of force. So this is the difference between the shell thin, shell thick, and membrane. Just ignore layer because it has its own cases. And modifiers, as we said, you can just adjust however the concrete behaves after being cracked, which is reducing bending moment. Technically, we're going to be working with reducing the bending moment. And the property notes, if you want to write something for yourself or for your colleagues. Now, the property data. The slab type, you have a different bunch of stuff here. So it's a slab, whether it's a flat slab or a solid slab, right? And you can add thickness, and for this case, it's 120 millimeters. Now, if my slab is a drop, so it's a drop panel that's used for the flat slab that's put on the top of the column. So I'm going to say it's a drop, and I'm going to give it the, let's say, the depth of 150, let's say. So what happens is the difference between a drop and a slab is there is your, there's your slab, right? And there is something like this as for the drop, and there's your column. So this is the drop. What happens when I define it as a drop? Well, I'm having this thickness, let's say, as 120, and then I come here and I have this thickness as 150. So it does automatically change the thickness on the drop panel or the drop area to the desired thickness that I've modified here. Let's remove everything and go back into stiff kind of slab. Is technically what I was telling you about within the define the frame sections when we said including the automatic rigid zone on top of the column head. What it happens is it creates a very stiff kind of panel or a very stiff slab on the head of the column, and its moment of inertia is multiplied by 100 times the normal moment of inertia of the section that you've defined. It's kind of more of something that's it's, as I said, you don't do it in construction, you just do it to tell the software that whatever is within, whatever joint or frame is within this zone is fixed with the column. Now we go into the next one, which is a ribbed slab. So a ribbed slab is pretty easy to like we said, it's called a hollow block or a Hordy slab. So it's something like this, and then you have your ribs, and there's a section cut, right? And let's even add the hollow blocks, something like that. So it's going to ask you for a bunch of parameters. It needs the overall depth, which is this thing right here, and it needs the slab thickness, which is this one right here, just the concrete slab. We can call it the TS or the TC. And it needs the stem width at the top, so the width of the stem at top, like this, or we can just use a different color, so like this, because sometimes when designing the Hordy slabs, you can have something like this. So the ribs are going to be kind of non-prismatic, if we can say that, or it can be in the opposite direction to ensure, so it can go like this. I'm just exaggerating the drawings right now so you can see the difference. So we ensure that the block right here, it doesn't fall down. And then it tells the stem width at top and bottom, we've done with that. Then the rib spacing, perpendicular to the rib direction. So he's asking about this, what's the rib spacing, which is usually going to be half a meter for the rib slabs. And then it says the rib is parallel to which direction. Now on the ETABS, as we said, we don't say X, Y, we say 1, 2 as or in RGB, so 1, 2, 3, or X, Y, Z. So it's parallel to the X direction, so the ribs are going to be in this direction. So you're technically, your slab is one way in this direction. If you change it to the local axis number 2, it's going to be, depends on the local axis of your slab as well, but we're just saying it's the same as the global axis, so your ribs are going to be in this direction. So it's going to be one way in this direction. Now on to the following thing, which is a waffle slab. Technically, waffle slab is a two-way rib slab, but you can increase the spacing between the ribs up to 1.5 meters. And it's just, it's actually in both directions, so you're not going to get the option of which direction you're parallel to, you're actually going in both directions, so it's something looks like this. So you have something like this, right? I'm just making it like kind of a big, so yeah, so this is the gap between them, this is the rib, this is the rib, and the rib. Now on to the next one, which is a mat, which is basically the foundation, and the mat thickness is going to be really relatively large, and you're going to have to use a shelf thick for that one. And then the footing, which is the isolated footing, so it's technically pretty easy. We're going to be doing those on the SAP 2000, not on the ETABS. And then this is what all you have to do know with the slab section. Now go to define, go to deck sections. Now what's the difference? If you can look here, a deck is technically, instead of using a wooden frame formwork, you're going to have a steel staggered kind of deck like this, and you're going to pour your concrete on top. So the concrete is going to look something like this after you're finished, right? All of this is concrete, and this is your steel deck, and the reinforcement is going to be something like this. And if the thickness is relatively larger than 160, you're going to have some reinforcement on top as well, right? And you can add like confinement like this, or you can add studs as well, like shear studs. Now, what's asking you is the property name, so you can just name it however you want it, and then the type. Filled is as we drew it. We have concrete filled and even until the top, so it looks something like this. Now, if it's unfilled, then you can only have the steel deck, right? And then if it's solid slab, then you're not gonna, your steel deck is horizontal, it's not ribbed, so it's not like corrugated, if we can say, so it looks like this. So let's go back with the filled one. And the material of the slab is the concrete technically, and the deck material is the steel or the properties of the corrugated sheet that you're using. Now modern type, it's a membrane, and you can't really change that. Now the modifiers, as we said before, display color and the property notes. Now what is this? It tells you what's the slab thickness, right, or the depth of the slab, which is the concrete, like this one. Or as you can see here as well, it's going to show you the TC, as if you can see on the right side of the photo. And then you have the rib depth, which is the depth or the height of the rib, which is the steel rib now. And then you have the rib width at bottom. And then you have the steel rib at the top and at the bottom. Then you have the rib spacing. Then you have the shear thickness of the steel deck, right? And which is like the thickness of the steel itself, which is 1 millimeter in this case. Sometimes it can go up to 5 millimeters. Now the unit weight of the steel and the shear stud diameter, which is this little bolt looking thing in the middle of the rib. And then you have the height of it, and then you have the tensile strength of it because it's steel, so it needs to be defined as well. Now let's go on to the section property. Now the wall section, it's technically as in the slab section, but this is just shear walls. So you're gonna, let's say, add a copy. Now we're gonna say name it, let's say, a shear wall 2, right? And we're gonna choose our property type, just leave it as specified, and the wall material with the concrete. And now for the notional size data, it's technically twice the volume, the ratio between the volume and the surface area, but since it's going to be predefined already, you're not going to really mess with that. Model type as well, shell thin, thick, membrane, or layered is going to be left as shell thin. Modifiers, as we discussed it before, the stiffness modifiers, and then the thickness. So I want my wall to be, let's say, 300 millimeters thick, and include the automatic rigid zone over area wall. So as we said before, regarding the columns, that we create a panel zone, like a little zone here, that whatever is inside this zone is going to be rigidly fixed with the column. It's the same thing with walls, but it's going to be just a little bit bigger. So whatever is within this zone of the wall is going to be rigidly fixed with the wall itself. And now we define section properties, reinforcing bar size. Now these are just the diameters of the bars, and technically it depends on the country and the production of your country. So you're going to like leave it as it is, predefined already. And then you go on to the link, as we were talking about, the link support or the support. Now what the link does, as we said, it connects the one or all of the degrees of freedom of a joint with another joint, as let's say with a beam and a column. So you can just name it however you want to name it, and it's going to be a linear kind of link. Now damper exponentially, bilinear, whatever, we're going to go with the seismic analysis, but this is a little bit advanced, so we're going to get into that later on. P delta parameters, if you have at P delta, that if you have a high-rise building and it's drifting a little bit due to seismic or wind, we're going to get to that soon. Well, not soon, but we're going to get to that later on. And then the total mass and weight of the link, you're going to leave it as 0 because, as we said, a link is just a hypothetical element that you're telling the software, well, these guys are rigidly connected to each other, or they are connected to each other with some kind of degrees of freedom. Now, this is the most important part, right? And with the direction which U1, which is the direction, the displacement in X direction, displacement in Y direction, displacement in the Z direction, and the rotation about X, rotation about Y, rotation about Z. So technically we're going to fix everything. If the connection is rigid, we're going to release the moments if the connection is a roller, and we're going to release the, let's say the X if it's a hinge, I'm sorry, and we're going to release the Z if it's a roller kind of connection. Otherwise, you're not going to really mess with anything. Now onto the next thing, which is a frame. We're not going to talk about these for now because these are a little bit advanced as well, so that's enough for it. Now for the spring property is, if you want to define a spring, technically when you're working with foundations, because you can't model the soil on here directly, so you're going to say, well, my soil is going to be like a spring. It has its elastic stiffness, it has plasticity, and it has its elasticity. So you're going to put it as a spring. You can define a point spring, line spring, or area spring. Soil profiles and isolated column footings, we're going to be working on that with the SAP 2000, so we're not going to do it here. Now diaphragms. What is a diaphragm? So as we said, our structure is consisted of joints, frames, and shells. So there is a joint, 2, 3, 4, and then a bunch of other joints everywhere. So in total, if we select everything, right, we're gonna have 48 joints in total in this specific structure. Now, you're gonna say 48 joints. Each joint has 6 degrees of freedom. So if you do the quick math, let me do it real quick, and it's gonna be 48 times 6. You're gonna have a total of 288 joints, right? So in total, you're gonna have a matrix that's 228 high by 228 wide, right? So technically, what a diaphragm does is that it connects all these joints together to, let's say, a central joint. So this is the parent, right? And now for this floor, it's one single joint instead of 24, because each floor has 24 joints in total. I'm going to connect all these 24 to this one linearly. So whatever happens to this joint is replicated to all of them, or whatever happens to these, let's say, children kind of joints or smaller joints is going to be replicated on the parent joint. So instead of having 24 in each floor and multiplied by 6, we're just going to have one joint multiplied by 6. So you have a 6 by 6 kind of matrix, and is going to cut down the analysis time tremendously on the mega projects. It's not a structural thing, again, so there is nothing when you're constructing. It's called a diaphragm, so it's just a hypothetical thing like a link, if we can say. And let's go back to diaphragm. You're going to see it's modifies. It's pretty simple. You just put the name and you add a rigid or semi-rigid. The difference between them is if you have openings, like let's say you have opening like this, somewhere like here, right? So your diaphragm can be semi-rigid because there is a void, right? And when is it rigid and when is it not rigid? If the opening is less than 40% of the total area, then it's rigid. If it's more than 40%, then it's semi-rigid, right? And it also depends on the specifications of your code and so forth. So it's not a fixed kind of ratio. Now let's bring our lovely slime back and go to peer labels. Peer labeling is, as we said, we have these shear walls, for instance, right? If we go to the 3D view. So this one acts as its own shear wall, and this one acts as its own shear wall. So these two are separate, but they're not. For me, I designed them to be one single shear wall that looks like an L letter. So what's going to happen is I'm going to combine them together with something called a peer label. So a peer label is technically something as well that's not a structural element. It's just telling the software that these guys are together as a single unit. So it's going to calculate the center of mass, center of rigidity for these two together, not for a single one, but for both of them. And it's going to display the forces and the straining actions for you as if it was, let's say, a beam. It's going to draw the bending moment diagram or as a column, shear force diagram and the normal force diagram as if it was a column. It's a really useful thing to do, so especially if you have a core or like a multi-dimensional kind of shear wall. Spandrel is the same thing. However, spandrels are like deep beams. Instead of being a vertical element, they're a horizontal element. So you're going to do the same thing technically. And then you go on to group definitions. Now, this is something as in grouping or as in making layers of something. So you're going to put all of the columns of the first floor, let's say, in a group. So we're going to call it like first floor columns, okay, right? And then you're going to, like, let's say, change the color to blue, and then okay. And then you're going to start assigning the columns of the first floor to this group. So whenever you run the analysis or if you want to change something, you can just do it for all of them at once instead of selecting them individually. Now, onto the second thing, which is a section cut. So a section cut is usually done after you run the model. Let's say I ran my model and I got like the bending moment stresses on the shell, and I want to see like a section cut. Like I want to cut here and I want to look through here, right? So if we can just, I want to cut along this line, like inside the page, or let me just do this, get this, and I want to cut along this side. So I'm going to see something like a line with the bending moments, like, you know, just varying on top of each other. And it's especially like if it's a field strip or it's a column strip. If I take a column strip around here, I'm expecting the bending stresses to be something like this, and something like this, and something like just go down like this, right? So this is technically a section cut. You're just cutting here, right? And you're looking at the slab like this, and you're getting your section cuts. Next thing we're going to be looking at is from the define functions, which is related to the seismic activity. So first thing is response spectrum. Now we're kind of defining a dynamic effect of this of the earthquake. And if you can see here, it asks you to input a bunch of codes. And the Egyptian Code of Practice kind of follows the Eurocode 8 2004. And then you're going to click on modify, and then, then let's just add a new function, right? And then you're going to have like the country. So let's say it's another country. And let's say the ground acceleration, which is the ratio between, like it's the factor that's multiplied by the g, which is the ground acceleration of the planet Earth, which is 9.81. And then you have some other different parameters that you can obtain from your code. And technically you're going to leave this as it is, and this is the response spectrum and the damping ratio of the structure, which is in the concrete buildings, it's usually 5%. If it's steel structures, usually 3% kind of damping ratio. But this is everything you need to know regarding the response spectrum. Now, going on to define, and then the time history technically is the same thing, but this is more kind of intricate and sophisticated way to do it. And generalized displacement is that you're saying, well, I have this specific joint, it moves in the direction of x, y, z, or it rotates around x, y, and z with a different amount, with a specific amount. As well, this is just you're not going to use that on the everyday kind of project, so we're not going to waste time into that. Now, mass source. So you're just defining what kind of mass will be taken into consideration with kind of resisting the lateral loads coming from the seismic or the earthquake. So you're going to uncheck both of these, and then you're going to check the specified load patterns, right? And you're going to add the dead load, the live load, let's say, and whatever kind of other combinations you have. And according to your code, which is like, let's say, the Egyptian Code of Practice, you're going to reduce the multiplier by a certain amount as it goes a little bit. You have to decrease the live load a little bit to ensure the maximum kind of, or the critical kind of state for the structure. And this is technically the mass source for you, and then you're going to just cancel everything. We go to define. Now P delta is, again, it's in high-rise buildings when you go like 12 stories, 13 stories, or even more. So you're going to say, technically, it's going to be iterative. You're going to repeat it according to the loads, and then you can add your loads, dead load, live load, with kind of a scaled factor, with like a different adjusted scale factor, and you're going to leave the convergence tolerance as it is. So it technically is like, I have the difference between a P delta and without a P delta is, let's just go real quick. You have two types of analysis, first degree and second degree. So if you have like, let's say a simple beam like this, and you have a distributed load on top of it, right? The moment is going to be like W by the L squared divided by 8, right? And it's going to be something like this. So this is the drop, which is WL squared divided by 8. Now this is the first degree analysis, right? Why? Because it doesn't take into consideration the deflection, which is long-term, short-term, whatever kind of deflection is going to happen to this beam. So it calculates the moment at an instance, right? But the second degree analysis takes into consideration the little bit of, let's say, deflection that's going to happen. So this is our beam again, right? And after a while from applying the distributed load, the beam itself is going to go something like this. So it's going to go down with a value of delta. So now, you don't, let's say you have axial force, and you have axial force on here, so the axial force is not going to contribute with the moment because it's multiplied by a distance of 0. However, axial force now, if you take a section cut, let's make it with a different color. If you get a section cut right here, and you want to get the string actions in this part, right? What's going to happen is you have the moment from the distributed load, which is WL squared over 8 as well. Now, you don't only have this one, you have the effect of the P and the delta, right? So you're going to multiply P by delta to get the moment at this point because, right, it has deformed, it has deflected a little bit, so it's the axial force is not really along the center line of the beam. And the further it deflects, the larger the delta is going to be, and the bigger the P delta is going to be. So it's literally a P delta effect because of the load and the deflection that's happening. Also, notice the difference between the notation of the P, of the P delta and P delta. So one is uppercase, and one is lowercase. So in the uppercase, we're talking about the deflection that happens because of the creep or because of the just long-term kind of deflection. However, the lowercase delta is when you have like a high-rise building, right? And it's affected by some kind of wind load, like this. What happens is the building drifts like slightly away from where it was initially. So by applying the load on top, or by applying its own weight, so there is a little distance, which is called delta. So this is another effect of P delta. So they're both are kind of have the same effect because it's a distance multiplied by the axial force acting on it, but it's just they just have two different notations. You can go back as you define again, as we said, with that was the P delta in a nutshell. Now load patterns is what kind of loads do you have? You have a dead load, which is going to be type, which is dead. Self-weight multiplier is 1. Technically, you're telling the software, well, you're going to calculate the dead load, which is the own weight of the elements, right? Which is the volume multiplied by the gamma. Now, you have something else, which is the floor cover, which is noted as FC, and it's going to be super dead. Or some other reference is going to be superimposed dead load. So super dead is like something on top of something. The term superimposed is as you put it into layers, like a sandwich. So self-weight multiplier is going to be 0 because we're going to be defining the amount of load of the floor cover. Now live load is live and its self-weight multiplier is 0. Now let's see what else. Then we have reducible live load. As it's like decrease a little bit, we have the roof live load if you have a truss or let's say a factory. So let's bring this back. And then you have this kind of, truss kind of factory, right? It's a pitched roof factory. And it's made of steel. So nobody, this roof is called inaccessible. So nobody can really get on top, and you can't like put some chairs and have a barbecue party on there, right? So maximum is going to be a couple of guys who are going to be cleaning the roof. So it's called the roof live load because it's way less than the normal live load. So it's this one, which is the roof live load. Then you have a bunch of different stuff, and then you have the seismic load, which is defined in the x direction, the y direction, wind load, the snow load, and the construction load. As we can say, when you're doing the constructions, you're working with, let's say, formworks, and you're working with machines, and you're working with men that are more than like, let's say the family, the floor is going to hold on to, let's say, 4 families. Each family has 5 members, so we're talking about 20 kind of people. Now when you are constructing, you might have 50 workers onto the floor, so that's taken into consideration if you want to be really conservative. And then the pre-stressing kind of force and the temperature as well, because with high temperatures material tends to expand, so the concrete and steel are going to expand a little bit, which is going to cause internal kind of stresses. And with the frost action, they're going to shrink, which is going to cause another kind of internal stresses. Now this is what was the load patterns. Shell uniform load sets is technically putting your loads as per meter, like per meter square as per area. And load cases is what you want to run the case, which is at this point we have the dead load, which is linear static, and we have live load, which is linear static, and then we have modal. We're going to go into the scope of the seismic analysis later on, but just as a quick reference, it's just telling you that, well, I need to take into consideration of the modal shapes of the structure, the way the structure is going to behave, which is something like this. Let's say this is my structure, and let's just use a different color so it's more obvious, right? And these are the stories. So first modal shape is the structure might go like this, right? And then this is the floor. And then the second modal shape, the structure might go like something, let's say in the opposite direction. So it's going to be something like this, and then like this. So it just depends on the shape of the deformation of each floor with the delta of each floor. So we're going to get into that like later on. And with defined load combinations, which is how do you want to put your loads? Because we don't just put the dead load, live loads, and floor covers like this. With the Egyptian code of practice, it's noted that the dead load is going to be multiplied by 40%, so it's going to be 140%. If you add another one, live load is going to be multiplied by 60%, by 160%. And the floor cover, let's say we don't have floor cover currently, is going to be also multiplied by 1.4. So anything that's dead, anything that doesn't move is multiplied by 1.4. If it's a live load, it's multiplied by 1.6. Now this is, let's say, the first combination or ultimate combination, 1. Now you have to define all the other combinations, which are going to be, let's say, the seismic is said 0.9 the dead, and with the live load it's called an alpha, and the alpha is regarding what's the use of the structure. So let's say this is a residential building, so the alpha is going to be 0.25. Floor cover is going to be 0.9 as well, so this is for, let's say, seismic. Now you add another combo for wind, and then you add another combo for, let's say, if you have a tank, so you're going to say for water, and you have another combo for lateral earth pressure. If you have like a soil, you have like a basement or a couple of basement floors. So you take into consideration the lateral kind of effect of the soil around you. So you're going to just define all the combinations you want to design according to, and you want to run your model analysis according to. Now, auto construction sequence. Now this is regarding the use of the D-beams or planted columns. So for instance, this is my frame, something like this, right? And on the top stories, I have something like this. And on here, I have a planted column that its support is the beam. So this is a D-beam, right? And this is a planted column, right? So what happens is, logically, when you start building, you're going to build this first, and then you're going to start by applying loads, by adding more loads onto it, and the more you proceed, the more loads you're going to be applying onto it. So what happens is here, if you say case active, and then it asks you the auto construction, which is auto sequence, that's the name, and then geometric nonlinearity option, you're going to see if you have a P delta, which you're going to just specify that this is like a structure that's subjected to a drift due to the seismic or the wind load, and if it's something like the voltage towers with the cable towers and stuff, so it's a large displacement because technically it just tends to drift a bit more. Now combine the number of storage and each config, just leave this as it is, and then exclude the group until the last step, which is like if you have 2 buildings next to each other and these 2 buildings are connected by links, you're just technically telling him that you're going to group these links in one. So let's say the group 1, and then you're going to exclude it until the last step, and then you're going to add your loads naturally, live load, dead load, float cover, etc. And then you're going to click on replace the dead load by the default as it assigns to it. So it assigns its different kind of dead load the more you go on. And when you run your model, you can have something like the number of steps. So the first step is just the D-beam with nothing above. So it's going to draw the bending moment. It's going to be something like this, right? And then when you start putting the second floor, the bending moment is going to increase, something like this. And the third floor is going to increase furthermore. However, you can notice the difference on these floors. On a typical frame without a D-beam defined, the bending moment is going to be kind of similar on each floor. However, when you do the D-beam thing, is you're going to just technically telling it that the deflection is not going to be that great, so this acts as a support for this, and this acts as a support for this beam over there. So the bending moment is going to be like reduced with a considerable amount. So this was the construction sequence definition. Walking vibrations, if you have, again, a sensitive kind of cladding or a sensitive kind of roof, and just me walking on top of it would cause some vibrations. So you're going to define you're going to use the RIDS model, for example, and then you're going to say the weight of the person. It's kilonewtons now. You multiply this by 100 to get the kilograms, the peak load factor, the walking frequency, and how many like steps would you take per second, etc., etc. And it's just like really something that you wouldn't be, you would not use it on your day-to-day kind of project. And that's pretty much everything for the define menu. Now onto the next menu, which is the draw one. You'll see the first option is the typical, like the typical cursor, which is select object. Like you don't even have to select it, it's just by default, your cursor by default. On the second thing is reshape object. It's a really powerful tool, and nobody, a lot of people just miss this one, which is, let's say you want to decrease the size of this a little bit, just doing it quickly as a sketch, or just, the dimensions whatsoever. You can just click on it and drag it down, let's see, halfway through, and there you go. This is a void. This is an opening without assigning an opening to it. So if you can look here, if we can remove the transparency, there you go. You can see this is an opening. Now let's bring it back, and let's go back to our plan view. Onto the next thing, which is draw joint objects. Technically, you're just drawing a joint, right? You're just setting a joint, because let's say you want to define a load that is a point load and it acts somewhere, but you can't really place it because there is no frame or there is no joint. You can just put this one, draw a joint object. All it does, it receives assignments, and you can draw objects around it. So it's as if you're drawing a beam or a column, but it's just a joint. And on the next thing is the draw beam, column, or brace objects. Now you can also find here on this quick draw menu, we're going to go start with a beam. Let's just select these guys, delete them for now, and let's start with a beam. Now technically it's going to give you a bunch of options. It tells you the type of line, it's frame, right, because it's a frame object, and the property, it says steel column. I'm going to go with a concrete beam for now. And the moment release. What the moment release does is it's asking you, how do you want your beam to be? If, let's say we drew a beam along this line, and there are some columns on these x's, right? So it's asking me, what do you want your beam behavior to be? Do you want it to be continuous? So the moment is going to be something like this, like up and dropping and going negative on the column edges, right? Or do you want it to be pinned? So pinned is going to be like as it's simply supported, right? So this is technically what is asking you regarding the moment release. It's continuous by nature, unless you want to do release the moment yourself. And then the plan offset, which is you're going to offset the beam. Like if I click on here, it's going to draw the beam from the point I've specified. If I did, let's say, I offset this by 8 meters, let's see, it's millimeters, so let's say 8,000. And we start drawing the beam again. Let's go somewhere like here. This is where my beam is. You see the little shadow down there is where my beam going to be, right? So this is technically the offset. It's just helpful when you're unable to reach the point you want to draw your beam onto. And then last but not least, not last but not least, but like this one is, how do you want to draw your beam? We've covered it with the edit menu when you want to just modify. So you can technically just draw it as an arc with 2 points and a center. So it starts with the center and then goes on to the first point, right? And then goes on to the last point. So this is, we drew a curved beam. If we can look into the 3D model, you see the beam is curved. Now let's go to our plan view. And last but not least, you can see here you can draw with some aids. Like you can draw your beam with like a fixed distance from X and a fixed distance from Y, or a fixed length. Let's say my beam is 2 meters. I just want to draw it 2 meters. So I'm going to click on the starting point, and you see it's fixed. No matter the orientation, my beam is going to be 2 meters long. And if we can go here onto the next one, which is going to say a fixed length and an angle. So a fixed length of 2.5 and an angle of 45. It doesn't change. No matter how I hover my cursor anywhere else, it doesn't change. And the measurement of the angle is the counterclockwise from the horizontal or from the x-axis. Now you go on to the second one, which is done. You're technically just drawing the beam however you like it, which is the default setting. And parallel to some sort of angle, so you're going to draw your beam without a specific length, but with a fixed angle. And then you're going to draw it parallel to the x-axis. Parallel to the y-axis. Let's start with this one. So it's going to draw the beam always vertically, and parallel to the x-axis, which is going to draw the beam always horizontally. Now, what if you want to draw multiple beams like this, and you want to draw the other beam like here? You want to just, instead of clicking escape, you want to remove this and start from here, but you don't want to click escape and have to choose the draw beam option again. What you can do is really simple. Let's say I'm going to draw my beam like this, and I'm going to right-click. So right-click, it only just cancels the drawing command, but I'm still within the draw beam. And then I'm going to start drawing this beam, and then to this one, and then this one. I'm going to click on right-click, and then I'm going to start from here to here. So this was the draw beam option. Now, there's a little bit of easier option. If your beams are, this is the quick draw beams. If you want to draw the beams on all of the grids right here, so it's going to give you a bunch of similar options, which is going to choose the concrete beam. Moment release, I'm going to leave it as continuous. And the plan offset, I'm going to leave it at 0. And then it says draw object using grids, mainly, that we're going to be working with. And what you're going to do is you're going to hold your mouse button, and then you're going to drag as you're selecting, and you see it starts highlighting the lines. And once I release, it draws the beam onto the grids. So if you can look at the 3D, now you can see I have a beam system, right? A panel beam system, let's say, and they are onto the grids instead of drawing them manually. Now let's go back to our plan view, and let's see the next one. let's just remove this real quick. Now, next thing is drawing columns, but it's on plan and 3D. It's a quick draw columns as well. We're going to choose our column section, which is concrete column. It's going to be continuous, that's fine. The angle or the degree is the we're going to see that in a second, but let's just, as I explained to you, we can either like hold your mouse button and then select where you want your columns to be, or you can just click, 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 and click. So what happens is it puts, if you look at the 3D model, it puts the beams, right? It snaps it to the whole floor. So these are the columns, excuse me, that we were drawing a second ago. Now, you can also draw the columns the normal way, but you have to be looking into like a 3D because you can't draw them really from a different perspective. You have to kind of try to align it, you know, and be careful so it doesn't look slanted. For easier drawing, you have to go to elevation, let's say. I'm going to go to, just let me get out of there, go to elevation. I know why it's not working for some reason. We can go to set 3D view, and we can go to the XZ plan, get this to 0, and there we go. You can start drawing your columns this way. It's a little bit easier, if you know what I mean. Okay, now let's go back to our plan view. Let's select these columns and go into the next one, which is the secondary beams. So technically, let's say we have our beam system like this, and on here we have some secondary beams in some kind of direction. This secondary beam option is going to help us doing so. So if you hover onto the slab or to the space between the beams, it's going to show you some red lines. These are the datum or the center lines of the beams you're going to draw. So if you click, there you go, you have 3 beams, and the more spaces you have, it just aligns and adjusts the spacing between them to fit in 3 beams. Now, if we look at the properties here, you're going to see that we're going to go with concrete beam, and when it releases, it's going to be pinned. You can make it continuous, but since it's a secondary beam, so usually it's pinned. And the number of beams is like the spacing between them, or you can set it to maximum spacing. So this maximum spacing between the beams is 2 meters. However, number of beams is an easier way to do it. We can set this to, let's say, 5 beams, and if you draw this, you can see there are 5 beams right here. Now you can draw it like it says, I'm going to draw your beams parallel to the Y direction. You can do it parallel to the X direction, right? So they go both ways, and you can make, my favorite option is normal to the near edge. So this side, it's parallel to the X direction, so my mouse is near this side, so it's normal or perpendicular to this side. However, for this side, my cursor is closer to this horizontal line, so it's going to be perpendicular to the horizontal line, and so on. I can, of course, draw like a grid system like this, but you get the point, right? Okay. Now, onto the next thing which is you can find here, and let's say I'm going to draw my beam system, and I want to make braces. So I'm going to just, from the option right here, from the sidebar, you can see the quick draw braces on the plan elevation or the 3D view. However, you can also get it from here, which you can go to draw beam, column, and braces and choose the quick draw braces. And what's going to happen is you see this little indication of the X mark, and there you go, that's your brace. And let's say we're going to brace it diagonally, just like this. Also, if we look into the 3D plan, the 3D view, there you go. If we just extrude the shape and we make it not transparent, there you go. You see, this is the grid system. And as well, we can draw onto the elevation side. So if we go to elevation, we go to, let's say, elevation A, I can draw my grid, my bracing system like this. And if you can go to the 3D view again, and there you go. This is the bracing, quick draw braces. Now, the next thing is the draw the floors or draw area objects, right? So first thing, it says draw floor or a wall. So technically it goes both ways. All you have to do is just change the property, right, from a slab. And right here, you're going to click, and you're going to click, and click, and click, right? So it draws a wall. And let me just redo the last part quickly. So you just start clicking on the parts that you want your slab to be, and you don't have to snap it back. You can just right click and it will connect linearly together. Now this is for drawing a regular shape. You can easily draw a regular shape by going to draw, or from the side menu, choose the draw rectangular floor or a wall, and all you have to do is hold your mouse button and drag as if you're selecting, and there you go, it drew it. And you don't have to do it on grids, you can just do it randomly like this, but you know, you have a grid for a reason, right? And one of the good features of the randomly, or I'll just call it the random draw floor, is just you can make it an irregular shape. So let's say you have a slab and this part is a void, so you can just do this, right? And right click, and there you go. You have your slab and this part is a void. So if you can look at the 3D, there you go, right? So we can also imply something that we've learned, and we can quickly draw columns, and we're gonna just put them like this. And if we can look at the 3D view, there you go, there are your columns. I know it does look like nothing, but it's just we're connecting the dots together. Now let's go back, let's undo the columns, and to the next one is draw a quick floor or wall. Same thing, you can either click on the panel you want to draw your wall in, and there you go, doesn't matter the shape of the panel, right? Or you can drag. Let me just select these guys, delete. You can, as I said, you can just click and drag, and the entirely selected panels are going to be like you're going to have a slab drawn inside of them. Now onto this one, it says draw a quick draw area around a point. So for instance, let's say I'm having a flat slab, right? And my columns are concrete columns, so let's just put the columns. And I want to make a drop panel. So a drop panel is like a little bit of a rectangle or a square, right, slab on the head of the column that the thickness is a bit bigger than the normal thickness. So what I'm going to do is I'm going to choose the quick, my bad, I'm going to choose the quick draw area around a point, and this is my point, right? The grid point B3. And then it tells me the shape of the object is going to be rectangular, and the property is going to be slab 1. Now the local axis is going to be 0 and 0, of course, don't want to change that. Now the dimensions. The x dimension is 1,000 millimeters, y dimensions is, or the y dimension is 1,000 millimeters. So it goes 1,000 millimeter in the x direction and 1,000 millimeter in the y direction. Let's say I make it 2,000 and, my bad, 2,000 millimeters and 2,000 millimeters. So it's a square of 2 meters each side, right? And you can just ignore the trim at slab edges. So it's just talking about this one. If you're in the slab edge, it's going to trim the sides. And let's click on this one. There you go. There's your slab. It's a square of the side of 2 meters. How do you want to know? You go to draw and then go to draw dimension lines. We're going to come to that in a minute. Or we can use from the view menu, measure and measure lines. You can click on this point and click on this point, and down there you're going to see the length is 2 meters. So it's 2 meters by 2 meters, right? And also you can draw a circular one. If you have a circular column and you want to have a circular column head or a circular drop panel, so you can go to circular. Let's just do this one, and it tells you the diameter. I want the diameter to be 2 meters, and I'm gonna click, and there you go. I know it's not a perfect circle, but as we mentioned, it's pointless to have a perfect circle because you'll never be able to do the proper finite element analysis for it. Now the next thing is draw walls on the plan view. So now we have the wall type is a pier. It's a spandrel, as we said, is a deep beam, but a pier is like the pier label that you assign it to the walls, and the property is the wall 1. Now, do I want to offset it? I don't. Unless you do want to offset it for your own reasons. Auto pier or spandrel label, no, because it's more preferable that you assign each wall to the pier that you want it to be manually. And what's the type of the wall? It's a straight line for now. We're going to see what other options do we have. And the drone control type is like, do you want to have a fixed length with an angle parallel to a certain ordinate? We've seen that with the beams and the columns. Now what I'm going to do is I'm going to click on this and drag down, right? And I'm going to click on this and drag down. Now notice here, something really important about drawing is where you're starting from and where you're going to. Because we've talked about the local axes, right? So the x-axis is always within the direction or in the direction of the element. So I've started from this point and I was going to the right. So this is my x direction, and if we apply the right hand rule with the thumb, index, and middle finger, the thumb is the x, right? So the z, or the z is going down, the z-axis is going down, and the y-axis is going outside of the screen. Now for this one, I started from here and I went there. So this is the x direction if we use the right hand rule again, and we see, so the z-axis is going to the left, x-axis is going down there, and the y-axis is coming out of paper. Now to check if we were right or not, we're going to go here, go to object assignment, and go to shell elements, because this is a shell, and go to local axes and click on apply. Now let's just remove this, and there we go. This is the x-axis, as we said. Z direction is down there, and the y direction is out of the page, or out of the screen. The x-axis is going down, the z-axis is to the left, and the y-axis is out of the screen. It's normal to the screen going towards you, not in the opposite direction. So the direction of how you're drawing your walls is really important, and I would prefer if you fix a direction that you draw your walls from. So let's say from down to top and from left to right, or from top to down and from left to right, like whatever directions you would like to, but just fix it so you don't face any kind of troubles calculating the moment around any of the axes, because of course it's different. So good thing, as you can see here, that all of my columns have the same orientation, so I wouldn't really be concerned about changing anything with my calculations. And then you can go to quick draw walls. It's technically you go to the side you want to draw a wall on and click on the wall, or you can alternatively just click and hold and drag, and it's going to draw the wall for you. So if you want to have this, like if you want to have the whole area covered with walls like this, if we can go to the 3D view, so there you go. This is what we did, and this is what we did. Now notice here the local axes of the walls, it drew it from left to right, and it drew it from bottom to up. So this is the default of the program. It's like I'm going to draw everything from left to right, and then from bottom to top. As you can see, this is what the default option. If we click on, also like if we click on here, it's not showing, but we can go to the plan view, story number 2. You want to draw a wall here, and if we refresh the view to see the local axes, there you go. It's going from down to top, and the axes are as shown. Now on to the next thing, which is, let's say you have a core like this, and you have an elevator inside the core, and you want to have an opening for the door of the elevator. So what you're going to do is, let's go to the elevation, or let's just go to the plan, to the 3D view, and to have a better visualization of the idea, here is your elevation, and the door shall be something like here. Or let's say for easier drawing for now, the door is going to be something like here, right? So you want to go onto the grid, which is this one, which is the A. So we're going to go to elevation A, and click on OK. Now you want to have a door right here. So you're going to go on to draw the wall openings, right? It goes for everything you can specify, width and height and bottom distance and left distance, but you can just like go like this. Start like you can just specify the beginning point, and then you start with drawing, and there you go. There is the door. There's the opening you have. And also remember, from the edit menu, we can go to edit shells, and we can go to divide walls for openings. And what's going to do is it's going to remove this opening completely and make it a void, and you're going to end up with having some 4 shells on here. 1, 2, 3, 4. Well, it should be 5. I probably misselected one of them. Oh, there we go. Yeah, so now we have 5 shells in total. So this was about draw the openings. Now, next thing is draw a link, and as we have explained before, link is just a hypothetical meaning that you're just telling the software that, well, I have these guys rigidly or connected to each other by some certain way, whether they are rigidly connected or fixedly connected, or they're pinned connection or whatever. So let's say we're going to draw a beam, right, from this one to this one. right? But my beam is not gonna get into the center of the column. It's just gonna be somewhere like, let's say it's a little bit offsetted like this, right? So this is my beam. And if I go to the extrude view, so you can see there's a little bit of offsetting here, whatever the reason is. So if you can't really fix this due to, let's say, any kind of architectural plans, you can go to draw link, and it's gonna tell you, well, the property is assigned to link number 1, right? And you're gonna click on the center of the column and then assign it to the center of the beam, which is something like here. So now these guys are not necessarily rigidly, but these guys are connected to each other with a link. And now if you go to define, or you can just right click on the link, it tells you link property is link 1. If you go to define, and you're gonna go to the link property, just give me a second to section properties, link or support property, there's link 1. If you click on modify, you can see that they're only connected within the X direction, so it's restricted the movement in the X direction. Now if you make it fix all, so it restricts all the 6 degrees of freedom, so it's a rigid or fixed connection. If you remove the rotation connectivity, so it's more of a hinge connection. If you remove the like movement in X or in the Z or the Y direction, I mean not the Z direction obviously, but in the X or the Y direction, so it's more of a roller connection. So this is about how to draw a link. Now next thing is, it says draw wall stacks, right? So this is something, as we have said previously, if you want to have a core, so a core is a bunch of shear walls connected together, and you define them as a peer label to assign their behavior as a one object, also to get the running analysis not only as, or to not get it as stresses or contour stresses, you can get it as bending moment diagrams as if you're drawing it for a column or for a beam. Now, if you click on this one, you're going to see some preset or predefined core shapes, right? So this is just a normal wall. This is kind of a different thickness kind of wall. So this is a wall with an opening, so let's say for the elevation door, and you can just browse through them and see the different types of them. So the most common two are these actually, and this one too. So these are like the most common 3 ones. So this is if you have 2 kind of elevators, and this is if you have 1 elevator, and this is as well for kind of, let's say, 2 elevators. But let's go with this one, right? Or let's go for a simpler one, which is this one. Now you have the name, you can change the name, right? And then you have the length in the X direction, which is L3. It goes from the interface of this wall to the interface of this wall. And the thickness, so the overall length is 3.3 meters plus 2 300 millimeters, so 300 millimeter and 300 millimeter. So in total you have 3.9 meters, right? Because 600 millimeters and 3,300 millimeters. And now it gives you the option to change the thickness, the overall thickness of the wall, and to change this height as well. And to change the height of the opening, so the height of the door, if you can see, we're going to look at it from the elevation, and you can change the width. So if you can say, like, I want my door to be 1.5 meter wide, it's going to be 1.5 meter wide. And I want my walls to be, let's say, 400 meter thick, it's going to go 400 meter thick. And now if you want to mirror it along the 2, so we remember that the 2 is the y-axis, so RGB, or 1, 2, 3, or XYZ, so 2 is the y, so you're mirroring it along the y. It's not going to look like anything because it's already symmetric along the y-axis. Now if you mirror it along the other direction, which is, I don't know why they call it mirror about 3, but it should be mirrored about the 1. However, let's just skip the formalities. So it goes the opening on the other side. And let's click on OK. Now it gives you the shear wall. You have 1, 2, 3, 4, 5, 6, 7. You have 7 snapping points. So the middle point, the very far corner point, the top left corner point, the bottom left corner point, and then the bottom right corner point, the top right corner point, and then you have these little corner points at the edge of it. So let's say we're just going to snap it to this, and it drew the whole thing automatically for you, so you don't have to assign anything. And if you can go to the 3D view, right, it draws it until the ground. So if you were drawing it into a high-rise building, let's say, you're just going to go to the final floor, and you're going to assign it once, and it's going to replicate itself onto the floors. So as you can see, here is my opening. If we can extrude the shape. So this is my opening, this is the door for my elevator, and this is my elevator core, and this is the other opening for the door for the elevator. So it's a really easy and handy way to draw elevator cores, or to draw a sophisticated kind of looking cores without having to go into much trouble. Now on to the next thing from the draw menu is the draw the slab rebar. So just in case you have, let's say, a predefined or pre-designed slab and you want to recheck the amount of concrete, the depth, etc., and the amount of reinforcement, of course, you can come here and draw the reinforcement and then run the analysis and check the design and not do the actual design. So what you're going to get is a bunch of options. The slab rebar layer is layer A. The rebar size is, which is the diameter of the bar. So it goes from 6 millimeters in diameter up to 50 millimeters in diameter. Now the the rebar material, which you've defined already from the material properties, and then you have the width on the left. So that means is you have a line to draw, right? So you're going to draw a line. So it's asking you what's the width of the left of this line and the width to the right of this line, similarly to the drawing the strip, the design strip, right? And then it asks you, excuse me, my bad. Let's go to draw rebar. Okay, now it asks you about the offset. It's just like the datum. You're going to go a little bit below the datum because your rebar is not in the middle of the slab. It's a little bit down or like below. And then it asks you the specification type, which is going to be total number of bars, right? You can make it about like a maximum bar spacing, but we're going to just put the amount of rebars you have, because usually it's something like, when you get a rebar, it's something like, let's say 5 to the diameter of 12 per meter run. So you have 5 bars, each of them are 5, or diameter of 12 millimeters each meter. And you can get something like 10, 5, 16 per meter run. So this is like 10 bars, each of them is 16 millimeter in diameter. So I personally keep it as the total number of bars, and it's going to be 5 bars as minimum per meter, and I'm going to have 500 or half a meter to the left and half a meter to the right. Now when I draw my rebar, it's going to look something like this. Yours might not look something like this, so you can go to Set Display Options, to go to Other Assignment, and from the slab rebar, you can uncheck the label, of course, and properties, just show each rebar with the offset, let's say, and we can even, you can just keep those, click on Apply. It tells you the spacing between the bars is 200 millimeters, which is the minimum, or the maximum, let's say, spacing between the rebars, according to the Egyptian Code of Practice, and the offset is 50 millimeters, or 5 centimeters, right? So they're offsetted at 5 centimeters, let's say this is the cover, right? Previously I said draws from the datum, now this is the cover of the concrete. So you can continue on drawing this for whatever the strip you want, and then check the design later on. Now, next thing in the draw menu is draw a design strips. So if you remember, if you've ever taken the flat slab course design, you break the slab into a bunch of different elements, which is the field strip and the column strip. So you assume that the columns are rigid supports for the slab. So you take a strip on top of the columns and call it the column strip, and you take another strip, like let's say right here, and you assume that the slab is broken into elastic springs. We're not going to get into that, but I'm just recalling or refreshing your memory quickly. So now we're going to draw a strip. We're going to call it a strip number A, right? The type is a strip, and then the design type is to be a column strip or a middle strip, which is a field strip or a slab strip. And then it asks you what's the start width from the left. So like on the left. So if you're starting from here, like this, say this is I and this is J, and you go into this direction, so this is the left and this is the right. So it's asking you, what should this width be, right? It's giving you the default, which is 1,500 millimeters, and the other side is 1,500 millimeters. And then it asks you the width on the left and the right side at the end. So this is the width, which is 1,500 and 1,500. So technically your strip is going to be something rectangular like this with the columns in the center. Sometimes the columns are somewhere opposite, like here. The column doesn't have a strip or doesn't have equal length kind of a slab on both sides. So what's going to happen is you're going to tell them, okay, this from the start, I want it to be fine. I want it to be 1,500, but on the right side there's nothing, right? So it's going to be 0 on the right side. And the same thing with the end. It's going to be 1,500 from this side, and it's going to be 0 from this side. So your column strip is going to be kind of a column strip, right? And field strip is the same thing. So what you're going to do is you just, let's get rid of these. You're just going to click on where you want to start and click on where you want to end. And there you go. You either right click if you want to draw more strips, like I'm going to do here. And I'm going to do one field strip, let's say, like right here, right? It's not, I didn't start properly, but anyways. So this is what would it look like. And you can also, after you're done drawing, you can right click to view its properties. It's going to tell you the name is A. If you click on anything here, it's going to show you the overwrites, the design overwrites. So the strip layer is A. The design type is a column strip. It's not a field strip. It's a column strip. And it's asking you, do you want to ignore the post tension when designing the strip? It depends if you have a post tension or not. If you don't have it, then it's not going to be even considered into the calculations. It's going to ask you about the rebar material, and you just ignore the cover from preferences, as in from the whatever you assigned onto the slab, or whatever you assigned from the code. Or you can just specify that I want my cover to be, let's say, 30 millimeters, and a reduced live load factor. You just the reduction. For the factor of reduction of live load, you're not going to really have to mess with any of these. It just depends on the code that you're working with. So this is the draw of the design strip. You can also show the width of your column strip. So if we draw another one, and let's say from here to there, right? And you go onto the set display options, but now it's a strip, so it's not within the object assignments. It's not one of the 3 main objects, so it's another assignment. And you will see here that it goes, you just look for, yeah, there's this design strip objects, and just click on show width, and if we click on apply, there we go. This is the width of the strip. So if we change it to, let's say, strip B, and we draw another one like here, right click, and there you go. So these are, this is how you can show the width of your strip. Next thing with the draw menu is the draw the grids. Actually, yes, you can draw the grids yourself, and let's say you want to draw the grid, another one, right, 4 meters away from the grid letter D, like the D grid. So on here, you're going to say the plan offset. It's going to say, listen, we need it to be 4 meters away, so we're going to put 4,000 millimeters, and we're going to click on this point, and click on this point, and there we go. This is our grid, right? It's labeled as number 1. You can change that with the grid settings, but you can do the whole thing from the edit or add or modify grids, right? Just in case you don't want to do that. However, this is a quick thing if you want to just draw your own grid for some reason. So this is your thing to go from the draw, and you go to draw the grids. Next thing from the draw menu is draw dimension lines. So we have something similar with the view, which is measure. Measure shows you the value of the magnitude of a distance on the bottom left of the screen. However, if you're going to draw a dimension line, it's going to give you the actual dimension as if you're drawing on some kind of, let's say, drawing on AutoCAD, right? So from the draw, go to draw dimension line, and click on the start point, and click on the ending point, and just drag it a little bit, and there you go. It says 24 meters, right, in this direction. And you can also, after you're done and you don't want to show the distance, you can go to set display options, go to other object assignment, and, go to general, and you're going to see dimension lines with the other special items, and just uncheck that one and click OK. Now they removed all the dimensions that are on your grid. If it's like, kind of messy and it's bothering you, or you can't properly see from them, you can just temporarily uncheck them and then recheck them later on if you need to capture any kind of measurements. Now the last thing we're going to be talking about with the draw menu is the snap options. right? Well, it's not the last thing, but yeah, pretty last, let's say. And it gives you the kind of option to snap. What are you going to snap to? You're going to snap to joints, to the end of the lines or the midpoints, which is a really good option. You can keep it by default, or you can just check it whenever you need it. Grid intersections, lines and frames, edges, which is the edges of the slab, perpendicular projection of the line, user mesh joints, if you have your slab meshed into finite elements, so you can snap into those. The intersections between frames, or any kind of intersection technically, because there's a grid intersection and then you have an object intersection. The defined grid, which is, I don't think you're going to use it. Intelligent snaps is, sometimes it's kind of glitchy. Sometimes, like if you have a lot of snaps going on, you might as well uncheck this one. You can keep it if it's not causing you any troubles. Parallel intersection, so you can technically be parallel to any line you're hovering onto. And the extension is self-explanatory. Now, you wouldn't really need to mess with anything, and you can also snap to the architectural layer that you've imported from, let's say, AutoCAD. We're going to see about that in another video. So this was the snap option. Last but not least, a little bit of tip. I personally like to draw using snap only, because before you draw, you just right-click anywhere on the your plant, like anywhere on here on this void, and it's going to show you the pretty last option, which is draw using snap only. You're just gonna, it's like a toggle button. You're gonna toggle it, and now it's working. And what happens is, when I have, let's say, my let's go to, okay, we have my beam, right, and it snaps onto the grid, right. Let's say I misclicked and it's not literally on, it's not directly over the point. It's not going to draw. No matter how long, no matter for how long you click, no matter how hard you click, it's not going to draw. You have to be on an intersection to be able to draw the beam. It's a really useful trick, and it saves you a lot of time if you're going to draw like the tiny bits manually, so you don't have to, you don't fall into the trouble or the issue of frames not correctly connecting to each other, or frames that are slightly offset from what they were meant to be. Next thing is the select menu. It's kind of pretty simple, but let's go through it. The first thing you go, select pointer or window, which is technically like the normal selection. You just, like, you know, either click on the object or just drag and hold and drag to select multiple objects, whether you're holding and dragging from whatever direction. Now go on to the second thing, which is select, and it's giving you the option poly, as in polyline. So you're gonna click, and then just to click, do not drag, and then you're drawing a segment of a polygon, right? And then click and click. And let's say this is the end of it, and I'm going to right click anywhere on the screen, so it has selected everything that lies within my polygon. Now this is kind of like, it's just a little bit, if it's the same thing as if you're going to hold and drag. It technically creates a polygon, which is specifically a rectangle, but just in case there is kind of an intricate or kind of sophisticated selection you want to do, and just a rectangle is not going to be fit for it, so you can use the poly. Now, intersecting poly, which is going to be anything that intersects with the line of the polygon, is going to be selected as well. So anything inside or anything intersecting with the line. Now, onto the other one is going to be line intersection. It's just technically anything that just intersects with the line. So these were inside, but they were not intersecting with the line, so they're not going to choose it. So if we go through them again, this is the general one. This is creating a polygon that only selects whatever lies inside of it. This creates a polygon that selects anything that either lies inside of it or in touch with its parameter, and this like creates a kind of a polygon that doesn't select the stuff inside of it. It only selects whatever intersects with its outer diameter parameter. Now, a coordinate system specifications. Now let's say, let's go to 3D view, go to select, and then coordinate system specifications is going to ask you it's going to give you three options: the XY plane, the plane, the XZ plane, or the YZ plane. Let's go with the XZ plane. So you're going to go here, this is the X, this is the Z plane, and you're going to click on any joint, and it's going to select everything within this plane, right? You can see it hasn't selected anything else because these don't lie on the XZ plane, only these shells. Now we have 7 shells selected, and I don't know what it calls, 7 shells technically, but anyways, it just selects whatever lies in this in this kind of plane, right? And then if you go on to select and select again, and you change the coordination system into the XY, let's just clear the selection, select again, go to coordinate system, and click on anything within the Y. You can see it selects everything in the XY direction. Now you have the 9 slabs or 9 shells, as you can see here, 16 joints and 36 slab edges. After the second thing, you're going to see object type. It gives you all the objects that are available on the ETABS. First is joints. So if you select the joints, it's going to select only all the joints. You can see here 32 joints selected. And the next thing is columns. Then next thing, you have to deselect. Like if you select columns and then select beams, the columns are still selected. So now, I mean, there are no beams obviously, but let's say you select the columns and then you select the floors. So floors are going to be any kind of horizontal slab, and walls are any kind of vertical slab, which are these ones. So you can see here, I still have my 4 frames, which are the 4 columns. I have 17 shells now, 1, 2, 3, 4, 5, 6, 7, 8, and 9 slabs, so a total of 17, and 68 edges. So now you can just go through. It's very simple, very straightforward. This is the select by the object. Second thing, which is more specific, which is select by the property. Now, I want to select all the concrete materials with the FCU, let's say 30, or the concrete 30 megapascals, or let's say the 4000 psi, and then click on select. currently it's going to select 17 shells, and it's going to select everything technically because everything was drawn using the same material. But let's say you have some beams that are drawn with a different material and you want to select those beams only, or those beams and a little bit of columns and a shear wall and a slab, and they all have the same material in common, so you can use this property. It also goes for the steel, the material of the steel. Now let's cancel the selection. Go again to selection by property, the frame selection, which is, let's say, now in here you have concrete beams, concrete columns, and steel columns. So sometimes, I mean usually, mostly, you don't have the same cross section of the columns. So you have columns, yes, but they have 10 different cross sections. And you want to choose the ones that have the similar cross section. So you're going to come here and choose the column with, let's say, 25 by 60, and it's going to only highlight and select those columns. And from the select menu, you can just go through the rest of the properties. Technically, anything that has a predefined property from here, right, from the selected section property, is going to be selected and nothing else. Now, labels is going to ask you a bunch of stuff, whatever you have labeled, as in, like, let's say we said before about labeling the shear walls. Now, as if pier label, and he's going to ask me what kind of pier label do you want. I don't have any piers defined already, but if you have, let's say, 5 piers, the pier label defined, you're going to see them here, and you'll be able to select them easily. Also, from the select menu, you're going to have groups. As it was said, we have, there is a wall stack group, but we actually deleted it, so just like deselect that one. Anyways, let's say, as if we said previously, we have a group for the bottom floor columns and the roof floor kind of beams. Anything of that is going to select that group itself. Now go to select again, and then you're going to see the stories. It just selects everything that's within the story. So we have all these kind of elements in the story 1. If we click on select, so you're going to see 16 joints, 4 frames, which are the 4 columns, 17 edges, 17 shells, and 68 edges. You have 9 slabs, and you have 8 shear walls in total. And that's pretty much it. Now you select all. That's just going to select everything you have on your project or on the window. Now if you go to deselect, it's technically everything, but in reverse. So you're deselecting this. Now invert the selection, which is Control K. Now I want you to just memorize these both selections because they're really useful. Invert selection and get previous selection. What's going to happen is, let's say I selected the middle slabs, like right here. And let me put back. Let me just toggle the transparency off. So I have these slabs selected, and I'm going to click on Control K, and I'm going to go from here and click on invert selection. So it's going to select everything else, but unselect these. So if I go to delete, you see only the 3 slabs that I previously selected before inverting my selection are still there. Now let's get everything back. And the last thing is get the previous selection. So remember when we were, let's say, editing or defining or something, right? And I told you, let's say from edit, and I was like moving something or replicating something, right? When you're done replicating, it deselects the object. And let's say you have multiple objects selected, like I have these objects selected, right? Let's just unselect this and select these. And I don't want to keep on selecting them manually every time. And I cannot use any of the other selection methods, and it will be a waste of time to keep on assigning these 4 slabs in a specific group for just this tiny task. What you're going to do is, let's say I replicated them. Let's go with the edit, or we can click on here and we can click Control+R. And let's say I want to replicate these into the second story and click on apply. So you see what happened is he cleared my selection. Now I want to do it again. So I'm going to go to select, and I'm going to get the previous selection, or Control J. Now the same selection is here. If I click on, let's say, I want to replicate those to the base for whatever reason, click on apply. There we go, they're in the base, and the selection is gone again. So if I click on Control J, I have my selection back. It's really handy. It's a really time-saving kind of feature and shortcut, so it's a really good one. And then a clear selection, if you have something like this selected and you want a clear selection, obviously you're going to click on escape, easiest, fastest way. But let's say you have your escape button just broken or something, you can go into clear selection and it does exactly the same thing. So this was the select menu. Now the next menu is the assign menu. It's a really important one, so yeah, just pay attention. Now, first thing is a joint. Now, what we're really concerned about this right now is the restraints. Right? It's asking you, what do you want this joint to be? Do you want it to be a fixed support, a hinged support, a roller support, or a free support? This is like nothing. If you click on this, you can translate, or you can move in all the 6 degrees of freedom. If you click on the fixed one, you're prevented from movement in any of the 6 directions, and hinged is technically you're prevented from translation, but you're permitted to rotate, and the roller is you're prevented from translation only in the vertical direction. If you remember from the link, if we go to define and then define section property and define a link and modify or show the link, it has the same degrees of freedom, right? So the direction, if I make it like this and I fix it in this direction, right, it is fixed within the Z direction, so it acts like a roller kind of. Now, how do you do it? Let's go to the 3D plan. By default, when you're drawing anything and it's touching the ground floor, the software is going to assign it as a hinge support. As you can see here, this is a little hinge support. If we can go to elevation for a better look, you can see this little triangle, it's a hinge support. So what you're going to do is you're going to select the hinges. You can select it from left to right, so it doesn't select anything else but the hinges that are included, or the joints that are included. Go to assign, go to joint, restrain, and I want to make this a fixed joint. And you see it changed it into this kind of indentation, which is a fixed base, excuse me. And you see the selection is clear, so I'm going to click on Control J to get the previous selection, and I'm going to make it a roller selection. It's gonna be like a symbol of like a circle, like a wheel, because it can like move in the X and the Y direction. And if I get the previous selection again, and I click on this one, which is just like, it's a free, it's not actually restrained to anything, and there you go. So good thing is about this one is, let's go apply, or actually if you want to choose all the joints, you're going to go to you're going to go to the plan view, going to go to base, click OK, and now you see all of your joints, select all of them. It's going to tell you we have 16 joints selected, and then you go to joint restrain from the assignment menu, and I want to make them fixed joints, right? And then if you go to the 3D, and I want to replicate this onto the next floor, I'm going to Control A to select everything, Control R to replicate, go to story, and to the second story, and I click OK. Now, as you can see here, okay, it doesn't show here, but sometimes if you replicate it, let's go to add a modifier, let's add a couple more stories, let's add stories, keep existent, let's add 6 more stories, and click on OK. Give it a second to load. It's replicating already. But my point is, sometimes when you replicate something onto multiple stories, you're going to see those supports on top here, right? So what you're going to do is, you're going to get to the elevation, let's say, and you're going to go, oh, not the elevation, you can just Control A everything, and go to the joint restraint, and make everything not restrained, and then go back to the plan, view, to the base, and select the base, right? And then assign whatever kind of fixed joint or hinge joint or whatever it is for that matter. The next thing is, from the assign menu, is assign a frame, which tells you to assign a section property modifier, releases and partial fixity, the end length offset, insertion points, local axes, input stations, and a bunch of different stuff. So if you can go here with a section property, so what I'm going to do is, let's say you drew all of your columns, and at instance using the quick draw column, right, command, but all of the columns are not the same cross section. Some of them are 30 by 30, some others are 25 by 60, and so forth. What you're going to do is, you're going to come to this one and select the columns that you want to have, you want to change their cross section, like I want to change these two, I want to make them a steel column, for instance. And then I'm going to click on apply. And you can see here, if I bring back my extrusion, you can see these columns now are steel columns, but these are still concrete columns. Same thing goes for beams, and this is just for frame section, so it works for columns, beams, and bracing. Now from assign menu, frame section, now property modifier. As we said, the building codes or construction codes require you to adjust some property modifiers for some elements. Why? Because after cracking of the concrete, the moment of inertia, let's say, is not going to be the same. So it has to decrease a little bit. Let's say we're going to change the modifiers for these columns, because these are concrete columns, and we're going to make them 0.7 in the moment about the y-axis, and 0.7 in the moment about the z-axis. Click on apply. So now they're having you can see here PM, which is property modifier, you see? So they have changed their properties. Again, back to the assign menu from the frame, go down to release or partial fixity. Let's go to the plan view, and I want to go to story number 2, and I'm going to draw a grid system of beams. I'm going to draw like a beam system, right? I'm going to do something like this. And I want to say that this beam is simply supported. It's not continuous. It's drawn as a continuous beam by default, right? If we can look here, I don't think it shows from here. Moment frame type, standard moment connection. If we can just... it's just standard moment connection because we probably drew it as a steel column. Anyways. But the moment is continuous, and I wanted to make it a simple beam. What I'm going to do is assign frame, and then go to releases and partial fixity. So it's asking me, what do you want to release exactly, right? I want to release the moment about both major and minor axes. So technically, I'm saying like the moment here is 0, and the moment onto here is 0. So it's behaving as a simple beam. And you click on apply, you're going to see 2 black dots. So the moment is released onto the start and the end of this beam. You can also release the axial load. So let's say you have an end gable column, right? And let's go onto the elevation view. And let's say you have an end gable column somewhere like here, right? Let's say like on this part. Let's draw something real quick, something like this, right? So this is our column. If we can go to extrusion, yep, there you go. And this end gable column I don't want it to be receiving, I don't want it to be carrying any kind of axial loads, because it's just there temporarily for carrying some of the wind loads, and then it will be removed when I'm expanding my project, when I'm expanding my factory or my building, let's say. So what I'm going to do is I'm going to select this column, I'm going to go to assign to the frame, releases and partial fixity, and I'm going to say, okay, I want this not to receive any axial loads from the top, right? So I'm going to release, so I drew it from bottom to top, so I'm going to release the moment release the axial load and the end. So it's not going to receive any axial loads from the end, it's going to just receive its own weight and the axial loads at this point. And I want to allow it to move in the up and down direction, so I'm going to remove it's just the axial force, that's fine. If you want to say I don't want it to carry any kind of shear force, you can also just release shear force and release the moment. So it's technically just anything on the top here. It's not there, it's like a cantilever column, basically. So it's a really handy feature, and you'll find yourself dealing with it quite a lot. And this was the releases partial fixity. Now about the end length offset, what you're going to do with this is you can actually Control A, you're going to Control A everything, and you're going to set the distance. What is it to begin with? So if you can go here real quick to have a small chit chat about it. What happens is when you go draw a bending moment diagram, this is, oh my bad, this is your column, this is your beam. So the bending moment diagram is something like, let's say this is just a typical frame, so it's something like this, and something like this, right? And you've got the supports here, of course, these are going to be your hinge supports. So what happens is, this is drawn by center lines, right? So you're drawing using the center line method. Now, what actually happens is that the column has a thickness, and the beam has its own thickness as well. So this region, right here, it has a huge depth. So I'm not really concerned about the moment on this one. I'm concerned about the moment about this section right here. So what the program does is starts calculating the moment onto this side. So the moment diagram is not going to look like this at the end. It's going to look more something like this. You still have the center lines. These are your supports. And when you draw when it draws the bending moment diagram, it's going to look something like this, right? It looks a little bit offsetted, right? Except it's not offsetted. The values are even less than the actual values. Why? Because it ignores this region. It's like, well, this region is really big and it can resist a lot of moment. And when you're actually designing onto, let's say, the shear strength of the beam, you get the Q max, and you get something called the Q corresponding, which is the Q on this side, right after half of the depth or after half the column dimensions. So this was a quick demonstration about what it is. So actually, in this side, okay, what happens is when you go to assign and frame and fix the length offset, if you want to get it the full dimension and the full length of the bending moment or the internal forces diagrams, you're gonna just say define the end and the offset for everything. It's just gonna be 0. Click on apply, and that's it. You see those little dots right here. This is the end length offset, and like the little dashes. And when you draw the bending moment diagram, it's gonna be, if I can just show you real quick, it's gonna be from here to there, right? Instead of being something like this, right? And instead of being, it's gonna be like something like this, instead of being something like this, right? So, or it's not gonna even go to the end. It's gonna go something like this. So this is technically what it is all about. And onto the next thing from the assign menu and the frame, you have the insertion point. What does it mean is, how do you want to insert your beam? You want the center line to be the middle, you want it to be the top, you want it to be the bottom. So for instance, if we bring our extruded view, I just click on the form shape and extruded view, okay, we go to 3D, and I want this beam, right, I'm gonna toggle the transparency so you can see properly, and let me just, yeah. So this beam right here, you can see the line, the dash line is on top of the beam, it's not in the middle. If you even right click on it, precisely, is going to show you where the insertion point. It says the center point, or the insertion point, the cardinal point is at the top center. Well, I don't want it to be at the top center. I want it to be at the middle. So now the middle center, and you click on OK. So now the beam, as you can see, the center line is the center of the beam, or the insertion point is the middle of the beam. However, the rest of the beams are inserted with the top. So how to fix this? You're going to just Control A, select everything. Go here, it's going to be centroid by default, and click on Apply. Now everything, if we go and show the extruded view again, now everything is fixed, and now these, the center line of it is in the middle. It's not on top anymore. It's in the middle. I don't know if you can see it properly. It's something like this. If you can see it here, there you go. This is the insertion point of it. It goes for beams, slabs, it goes for any kind of element technically. Now, next thing is from the assign frame, you're going to have the local axes. Now, let's say you have drawn, or you want to just change the local axes of some element for whatever reason, right? Let's bring back to the normal view, and let's select this one, right? We're going to select this frame, as you can see here. Now, you still see the insertion point is in the middle, as we have adjusted previously. Now, I want to rotate these axes by, let's say, 90 degrees. And to show you everything, I'm going to close the extruded view. I'm going to go here. I'm going to go Object Assignment, to the Frame Assignment. I'm going to check the local axes on. I'm going to click on Close. So this is my local axes. If I rotate it by 90 degrees, and I select this one, click on Apply, as you can see, the z-axis now is rotated by 90 degrees. So it turned, and if you can look at it from the start to end, so like this, it turned 90 degrees clockwise. If I want to bring it back, I'm going to say -90. So you can see it turned into the other direction. I was just going to actually click on just 0 because I want it to be in the original position to bring it back to the original position, right? So negative is anti-clockwise, positive is clockwise, and this is how you're rotating it. To actually change the start and the end, we did that from the edit menu, and we did it from edit frames, and it's reverse the frame connectivity. So there you go, and then you can just alter the direction of your beams, or of your elements technically, if something went wrong, or if you want this to be in some certain direction that you've already adjusted your calculations regarding to. Next thing in the assign menu you can find is the output stations. Well, technically it's asking you how many stations do you want me to calculate the forces and the bending moment diagrams in, because what happens is, let's draw a little, let's say a column, right? Just make it a normal looking column. I don't know what's wrong with it. Something like this, and this is like a fixed column, right? So the stations, now we have 3 stations, so it's going to calculate at this one. So this is, let's say, station 1, and then station 2, and then station 3. So it always spaces out those stations equally, right? So this is spacing, and both are equal. Now, if I want to make into 10 stations, what's going to happen? What's going to happen is it's going to divide the length of the column. Let's say the column is 10 meters high, and it's going to divide it into 10 pieces, each piece, or 10 spacings. Each spacing is 1 meter high, and it's going to start calculating the forces and this section. So when it draws the bending moment diagram, it has the force at this section, this section, this section, this section, until the 10th of them. And how do we view that? Well, you guessed it, from the set view options. You can go here and say, where is it going? Object assignment, regarding the frames, it's the output stations. Click on apply. Now you can see this is number 3, which is the minimum output station, number 3, number 3, number 3. And on the beams, or the horizontal frames, it says 500. Why? Because usually, let's just try to straighten this out. When you draw a bending moment on a beam, you don't do that. It's not like a straight line, right? It's more of a parabola, something like this. So you need a lot of points to give you this kind of parabola feeling. That's why it has a 500 stations. So it's calculates, so let's say this beam is 5 meters, right? is going to divide it into 500 pieces. So each piece is, if you say 5,000 centimeter, or I mean 500 centimeter, my bad, divided by 100 or 500 piece. So each piece is 1 centimeter in length. So it calculates the stress and the forces at this point, at this point, at this point, 500 times for the beam to be able to draw and give you this smoothly looking parabola. Now the assign menu, we go onto the shell assignment. Now a slab section. So our slabs are slab 1. I want to turn this into plank or any kind of other predefined section from the define menu. So you're going to click on it and then select your object and click on apply. So all of them are slab 1. Let's just turn off the output stations. So all of them are slab 1, except for this one is plank 1. So this is how you technically assign the slab. Next one is the deck section. If you have a deck and you just want to assign it, it's the same thing. Now onto the wall section, right? Same thing, different thing. You're just going to choose, apply. Everything is going to be wall 1 if we rotate and see, right? And this is wall 5. Now also to rotate, you're going to hold onto your mouse button, the wheel button, as if you're panning, and then hold on to shift at the same time. So it's going to rotate about a pivot in the middle. There's just like a quick tip along the way. Now onto the assign menu again, from shells, openings, same thing, different thing. I want this one to be an opening, right? I can click on apply and there it goes. I can do this in a different fashion. I can right click on this one and with the opening, it says no. Well, I'm going to turn it into yes. And bingo, there it is. It's an opening. Again, from the assign menu, go to shell. The stiffness modifiers as the same as the property modifiers for the columns. You're just going to change due to the cracking of the concrete. And then with the shells again, now thickness overwrites. If you have the thickness and you want to change it, just you use these thickness overwrites. However, it's grayed out for now. You can just manually change it from the section property, or you can just go to define section property, the wall slab section, let's say, and the slab, double click to change. I want this to be 160 instead of 200, and click on OK. And then click on OK. So all the slabs that are assigned to, or like all the floors that are assigned to slab 1 would have the thickness of 160 millimeters. On to the next thing we're going to see is the insertion point. Again, what's the insertion point for this one? I want it to be, we probably assigned everything to have an insertion point of the middle. No, it says the cardinal point is on top. I want it to be at the middle, and I can do it from here. I want it to be at the middle, and I click on apply. So this one is inserted from the middle, from the center line of the slab. These ones are inserted from the top of the slab. Yeah, it's just a matter of, how do you want to, it's just, I don't know, it's kind of like the same thing when you run the analysis, really. Doesn't really matter, except for some kind of special occasions, but yeah. Next thing on the assign the shelves is the diaphragms. You're going to assign a diaphragm to all these. So if we select everything and we assign a diaphragm, click on apply, it's going to connect all the joints, as you can see, to a certain central master point. So it makes the time that it takes, that your laptop takes to run the model and do the analysis much, much faster. Again, from display, go to edge release. It's kind of the same as the moment releases on the edges, but this is for slabs. And now you got the ribbed location. If you have a ribbed slab, or if you have a waffle slab and you want to change the location, it says note assignment only applies to waffle and ribbed slab, so it's not going to be actually working on the solid slab that we have right now, but it just tells you the location of the rib from the point X and the point Y. Next thing we have under the shell is the local axes of the slab. If we can toggle the view from the set display options, go to object assignment, the shell, go to local axes, and click on OK. Now these are the local axes. If I want to turn this, same thing, 90 degrees. It's going to go, you're looking this direction, you're looking in the direction of the X axis, and it's going to turn it 90 degrees. If it's positive, then it's clockwise. Click on apply. There you go. Next thing with the assign menu from the shells is the local axes. Now, if you remember from the frames, we would look into the direction of the x-axis, right? And it's going to rotate the y and the z-axis. If it's a positive value, then it's going to be rotated clockwise. If it's a negative value, it's going to be rotated counterclockwise. However, for slabs, if we're going to show the local axes, let's just remove this for an instance. There we go. For slabs, how is the slab inserted, right? The slab is an area, and for an instance again, this area, the x direction is not the governing one, right? It's actually the blue one, which is, remember, R, G, B, X, Y, Z. So it's the Z direction, which is the governing one. And what does that mean? Which means is when you change the rotation angle for it, it's not going to rotate about the x-axis. It's going to rotate about the z-axis, which is going to be something like this, right? And which makes more sense, because if you rotate it on the x-axis, the slab is going to be vertical. It's going to be something like this. It's going to be like a wall. So if you're rotating around the x, that doesn't change how you look like. Now, let's just remove everything. And let's say I want to rotate this by 90 degrees. So if I'm looking from at the tail of the arrow, I'm going to rotate clockwise. If I'm looking at the head of the arrow, something like this, let's go to plan view section, story number 2. Now I'm looking at the head of the arrow, so I'm going to be rotating counterclockwise if the value is positive. I know it might seem confusing, but if you do it yourself, you're going to get your head around it. So I want to rotate this slab 90 degrees. It's positive, so it's going to be counterclockwise because I'm looking through the direction of the head of the arrow, and there we go. It's rotated 90 degrees. Now if I wanted to go back to the previous position, I'm going to select it. I'm going to click on 0, and there we go. If you want to change from a current orientation, now if I go 90 like this, it's going to go, it's rotated 90, and if I click on 0, it's going to technically rotate it from this current position with 0, so it's not going to go back. To send it back, I have to click on negative, I have to input negative 90 degrees, so it goes back to the default. Now, it's not hard, it's easy, believe me, so you don't have to worry. Now, area spring, we're not going to be dealing with that for now. Pier label, as I said, you assign these, let's say, if we go to 3D view, So you're assigning these shear walls all together as a single pier, right? So these four, you have 4 shells now, you're going to assign them as pier 1. So they're assigned together as a pier label, so they're working as one unit, and you can actually have a bending moment diagram for them instead of a bending moment stresses, like the shells, as we will see later on. Next thing with the assign from the shells, and actually that's, oh yeah, the floor auto mesh. So technically you're going to leave the slabs for the floor by default, and you're just going to click on OK. So it's a floor auto mesh, and then you click on assign, shells, and then walls auto mesh. You're going to change that into rectangular mesh, or you can just put it into, like I would just put it into rectangular mesh, and I'm going to click on advanced, and I'm going to turn my mesh. My mesh size preferably is 0.5 meter if you don't have such a huge project. If it's a really big project, you can put it into 1 meter. So this is like the dimensions of the square of the mesh. Click OK, and click on apply. It says now select, just select everything because it's going to only apply to the walls. Click on OK. So now if you close this, you have the slabs are in default, the walls are in auto, and that's it for the slabs auto mesh. Our edge constraint, so it's asking you about this edge. Now we have a support on here, a support on here, but you can turn it into, because actually the whole thing is resting on the ground, so it's not only 2 supports. So it's asking you to create edge constraints around the walls and the floors. You're going to click on apply. So now this is edge constraint, so now it's all of this is a support, not only these 2 points. Now this was everything we need to know about the assign with the shell. Now if you go to link, it's pretty easy. The link property, as we have mentioned before, is just asking you about the properties of the link and the weight of it, the mass, and what is it fixing, what is it releasing. Also its direction, because you want your link direction to be in the same, the local axis, you want it to be in the same direction with the object. You're linking it with the other object, like a beam with a column. You want it to be in the direction of the beam, because it's an indication of the continuity between the beam and the column. And next thing is a tendon. That's regarding post tensions. We haven't defined any tendons for now, so we're going to leave this for now. Now the joint loads is, you're going to say I have a force, I have a pointed force onto this joint, right? So I have, for whatever reason, I have a concentrated load on here, on this joint. So I want it to be, it's regarding, like, it asks you which load pattern I'm going to put it. We're just going to define another load pattern for this concentrated load. And if you look at your axes, which is x, y, and z, right? This is the x, this is the y, this is the z axes. I want the global x to be, or actually I want I wanted the force to be like this, to be pointing inwards, something like this, right? So I'm going to assign into the negative y, right? I'm going to click on negative 1,000, let's say, or 1,000 kilonewtons. I'm going to click on apply. So you're going to have, if you just remove this, you're going to have 1,000 kilonewtons applying onto this joint right here. Let's say you want to apply in the middle of the slab or in the edge of the slab, but you don't have a joint. You cannot apply that to a joint. If you click on apply, you see nothing happens. No selected objects were found to receive this assignment because it applies to a joint. What you're going to do is, from the draw menu, you're going to draw a joint object, as we said before, and you're going to make just joint object. If we can go to the elevation, I want to go to elevation, let's say A, B, whatever, and I'm going to draw my joint something like this, and I'm going to plan my offset into, this is the y direction, right? So I'm going to plan it into, like, let's say 4,000 millimeters in the y direction. I'm going to put my joint there. So this is my joint, right? And I'm going to put my force into the x direction now because I want it to be inside. So I'm going to put 1,000. Click on apply. So now this one, if you go to 3D view, there is 1,000 points applying into this direction. I know you can't see it because it's not like, if we go to, now this is display options. I want it to be, if you can go here, here. So you have it like, you just change this because the insertion point we have it on top. Yep, I want it to be in the middle. Okay. Now you have the 1,000 kilometers. It's acting onto the slab. You can also change the insertion point of the slab to be at the bottom. So your force is acting directly at the middle of the slab. And again, it's just, you're not going to be using that more often. It's just for some special occasions. Now assign joint loads, now ground displacement. If the soil, this is regarding the soil, so we're not going to be dealing with that. And the temperature, since you can have some kind of shrinkage and expansion, but we're not going to be doing that with the joints. Second thing is frame loads. Now, there is a point load on the frame, right? So you're defining like a frame load assignment, it's a point load, and you're just going to put your parameters. I'm going to say it's a live load, and I'm going to say it's force. It's not moment, it's a force, and it's in the direction of the gravity, which is against the z-axis, or it can be in the direction of the y, the global y-axis, and the global z-axis, or the local x-axis, local y-axis, or local z-axis. It depends on the direction you want it, but generally or usually, it's in the direction of the gravity. Now you have 3 options here: add to existing loads, replace existing loads, or delete existing loads. If you're going to add to existing, by default, it's replace existing loads. So let's say on this beam, or whatever, we don't have beams, but if there is a beam here that has already assigned a point load with live of, let's say, at the beginning we have, it's just like, let's say we have mids, this is like the distance, the absolute distance, right? Or like the relative distance from the end, and the absolute distance is going to be the length of the beam. However, let's say you have, on the first quarter of it, you have 100 kilonewtons concentrated force, so it's going to look something like this. If we draw our beam, something like this, right? So in this quarter, it's going to have a concentrated force of 100 kilonewtons. What happens when I click on add to existing loads, like on this one, what happens is I'm going to assign 100 here, so it's going to add another 100 kilonewtons in 2/3 or 3/4 of the beam length. But what happens when I click on replace existing loads, it's going to remove this one, right? It's going to delete this one and assign only the new load right here. And if I click on delete existing loads, it's going to delete everything technically, but not with the beam. Of course, it's just going to delete all the loads on it. On to the next assign. We're going to go to frame load, distributed loads, which is like, if you have a wall, you have a distributed load on top of it, and if the distributed load is constant, right? So it goes something like this. There's your beam again, and you have a constant distributed load like this of, let's say, 14 kilonewtons per meter run. So you're just going to put on here, it's a uniform load, so you're just going to put 14 kilonewtons, and it's going to assign the whole length of the beam with 14 kilonewtons. However, if your distributed load was not uniform, it was more of like a triangle, like this, right? You have here is 14, on here is 0, on here is 0. So you're going to have to tweak this a little bit. This is going to be 0.5, and this is going to be, let's say, let's say this is going to be 0, this is going to be 0.5, and this is going to be 1, and you're going to put on this one, you're going to put 14, and the rest is 0, and you're going to remove this one. And then what happens is, it's going to say, okay, at the first station, which is distance 0 from the beginning, so this is I, this is J, there is 0, okay? And then it goes, second station, 0, 0, okay? Third station, which is at the middle, is 0.5 from the total length, it has 14, okay, so it goes up, it adds 14 kilonewtons per meter run, and then again it goes to the last station, it's like, oh, it has 0, okay. Now what if I want to make a trapezoidal kind of load? So you have your beam like this, and you have a trapezoid like this, right? What's going to happen is, it depends on the parameters or the length of the trapezoid, but just for the sake of simplicity, let's say this is at a quarter of the beam length, and this is at 3/4 of the beam length, and this is 14 kilonewtons per meter run, and this is 14 kilonewtons per meter run. What's going to happen is, on here, you're going to bring this back to 0.25, and you're going to bring back this 0.75, and you're going to say, okay, at the beginning, it's 0, as you can see, and then it goes up to all the way up to 14 at the second station, which is quarter of the length, so it goes 14, and it's constantly 14 until the 2/3 of the station, of the length of the beam, and then at the end of the beam, it's 0, so it goes something like trapezoidal. Also, again, for the sake of showing you, I'm going to draw a beam quickly on here, let's say, and I'm going to remove whatever this is. I'm going to draw a beam. Beam is going to be from here to there, right? And I'm going to go to 3D view, and then I'm going to select my beam, right? I'm going to just, I'm going to select everything. I'm going to unselect this one, right? Or actually, we can do a trick. We can select this one, right? And then we can go to select and then revert selection. I'm going to delete everything. So everything is deleted but this beam right here. So now I'm going to select my beam. I'm going to go, okay, I want it to be this way. I want it to be on the dead. I want it to be everything. I'm going to click on apply. So this is how it looks like. You see, that's a trapezoid and with a 14 kilonewtons per meter on the parameters of it. Now, if you want to make absolute distance, it depends on what beam I'm selecting. The distance of this beam is 8 meters. So I want at the meter 0 is 0. The meter 2 at the station number at 2 meters from the beginning is 14. At the station from 6 meters from the beginning is 14, and the station 8 meters from the beginning is 0. Now what if I want to make this a triangular load? What I'm going to do is, easy way is to go make it like a relative distance from the end, right? Choose your beam, and then go onto, okay, I want it to be a station 0 and half span or midway, and then at the end. So this is going to be 0.5, this is going to be 1, and this you can leave it at 0 because it's the end of it. I mean, there is no, you can put it at 1 as well. It's not going to really change anything. And then on here, you're going to only need the 14 kilonewtons to be in the middle. And if you click on apply, it's going to look something like this. So now you have a triangular load for whatever reason. Now, what if I want to make it into more of a triangular load, but I don't want it to be isosceles? I want it to be something like this. It starts from here with a 14 and goes into here up to there on the 0. It's easily done. You want it to be spanning the whole length, so we can go onto absolute distance from I, right? And this is your start. That's because the red arrow is going from right to left, so this is where you start. So at the distance, the start distance is going to be 0, so I want the load to be 0, right? And at the end distance, which is going to be 8, I want my load to be 14. And you have it selected, and click on apply. Everything is deleted for some reason. Let's just redo it again. Okay, there is our old beam, and click on apply. There we go. So now you have the isosceles triangle, the right angle triangle with the 14 kilonewtons on the edge of it. So this is how to assign the uniform loads onto frames. Now, what if you have a slab? Let's say we're going to draw a slab on here on the second floor with a quick draw, right? You're going to draw just a bunch of slabs here, and you want to draw a line load, but you don't have a beam underneath. You can't do that because the assign menu is only for frame loads. You cannot assign distributed load like a line load on a slab directly. So here's a good trick. You're going to go to draw something like a beam, but it's not actually a beam. It's called none. What happens is it puts a frame. It's a frame, right? But it has no thickness, no width, no height, no length. It just has like the length you define, but it has no sectional properties. Moment of inertia is 0. The first moment of inertia, the first moment of area is 0. Everything is 0. So when it goes to the stiffness matrix, when it's solving the analysis, it's not taken into consideration. It's only there to carry your load. So what we're going to do is, as we said, the type of line is frame. The property is none. And now we're going to draw whatever we want it to be. We want it to be from here to there, right? So we have our frame here. So we can go and assign frame load, distributed load. And I can go and put, well, I want this to be 0, and I want it to be uniform load of 14. And if I go to our 3D view, I'm going to see a 14 kilonewtons per meter run defined onto this line, which isn't actually anything, it's just a none kind of line. And if you want to select all the null lines in your project from the select menu, go to select, and go to object type, and you'll see something called null lines, which is the nothingness that you drew the distributed load on. You can also see you have something called null areas, technically the same thing. If you have this kind of slab with two different loads onto each other, like it has on here 14 newtons per meter square, and here it has 5 kilonewtons per meter square, and you don't want to split it into two slabs, you can just use the null slab option to draw the load that's needed. Now, next thing from the assign menu is the shell loads, which is you're going to be concerned about the uniform loads. So if we go to the plan view and draw a shell, like a slab, real quick right here, and then you're going to assign the uniform load in the live load, let's say, with a uniform load of 2 kilonewtons per meter square. You click on this, click on apply, and there you go, you say 2. You can see it says 2, right click on it, go to loads, then from uniform pattern, live, then uniform, 2 kilonewtons per meter square, and the direction is the gravity, and this is the value. You can also view that by going to display, load assigns, shells, and there we go, it's going to tell you the pattern is live, and then it's going to ask you to, you want to show the contours, which is you're going to be going for this one, click on apply. Now it's going to draw a color, and whenever you hover onto it with your cursor, you can see 2 kilonewtons per meter square, and onto here, you see the different colors, since if you have like any kind of different slabs, and it's bluish, so it's around here, but it's easier to just read the number off your cursor when you're hovering on it. Now onto the next thing, which is the analyze menu. First thing you're going to see is the check the model. So what you want to do before you run the analysis is check your models if it has any errors or warnings. So the length tolerance for checks is going to ignore whatever is below 1 millimeter, but you're going to it's the minimum tolerance. You want to keep it this way. Now, what do you want to check, right? So if you're running the model and then you had kind of warnings and it's telling you any kind of area, so you want to check the shells, so you're just going to click on shells. But if it's the first time you're going to do it, you're just going to select everything and you're going to click on OK. So now it takes its time and it's going to show you a window, like a dialog. And it's going to tell you if there was any kind of errors, or if it was, you see, model has been checked, no warning messages were generated, which means everything is properly connected to each other, and there is nothing unstable, or there is nothing that's causing any troubles in your model, so you can safely run it for now. Second thing, it says set active degrees of freedom. Which are the active degrees of freedom you want? I mean, of course, we're modeling in the 3D, so you want to have all of your degrees of freedom, all of the 6 degrees of freedom active when you're running your model. Now, then set load cases to run. Let's say you want to just model your building against the seismic, so you're going to save your time from running. Let's say you have 52-story kind of building, right? It's a skyscraper, and you don't want to waste time in running all the analysis. You just want to check the modal, which is the seismic. So you're going to select these two and click on do not run, right? So you can just click on this run or do not run cases. So it's not going to run these two of them. It's just going to run the modal, which is going to cut the analysis time tremendously if there is anything, as I said, if it's a mega project and you want to check something specifically. Now let's set it back to run. And we can go to analyze again and advanced simplified options. This is also regarding your laptop or the computer specs. So you're not going to be, you don't want to do anything. It just depends on how well you're into hardware, how well you understand the hardware. So it just chooses the optimum. So just keep it this way. It just depends on, you want a standard solver, advanced solver, multi-threads, which is going to use more processor. It's going to, if you hover onto it, it says the stability checks, it's good, the problem size, it's better, and the best is solution speed. So it runs the analysis and the maximum speed. Advanced solver, which is going to be the default one, it gives you a better stability check, a best problem size, and a better solution speed. And then the standard solver is going to give you the best stability checks, a good problem size, and a good solution speed. You can just keep it on advanced. And the processing, which is like which processor you want to use. Do you want to use the graphical user interface process, or do you want to use the separate process? Just keep on auto, so it alternates between them, whatever it fits the best. Now, second thing from the analyze here, I mean, not the second thing, but this is like the fourth thing, or the fifth thing from the analyze, is advanced designs and response recovery options. So it's telling you the number of threads for design, it's the number of the threads of your processor. Again, this is hardware related, so you're just going to keep it this way. Now, what's really important here is the automatic mesh size for floors. Remember when we set it to default, right? All you need to do here is just change the value of the maximum mesh size to be half. If it's a moderate to large project, if it's a mega large project, you can make it 1 meter. Right? Then onto the analyze, the rectangular meshes for walls. We've already set that from the advanced options in the assign menu, but you can also do it from here, from the analyze. You can set it into half as well, so the meshes are along of each other, of the walls and the slabs. Now, last thing, which is run the analysis, which is going to start solving and giving you the reactions and the stresses, the forces, the diagrams, and what so forth. You can do that by either clicking on from here, go to analyze and click on it from here, or just click on F5. And notice, when you run the analysis, you're not going to be able to modify anything unless you unlock your model and delete the previous calculations, and then adjusting or changing whatever parameter you want to change, and then rerun your model. So you got to check your model 2 or 3 times before you start running if it's a really big model, so you don't waste a lot of time. Now, I'm going to skip the display, design, and detailing for now, and I'm going to go into options. First thing you see is display units, which is, since we're using metric SI for this project, is going to be meters, centimeters, millimeters, radians, and degrees, right? Kilonewtons and Celsius. Also, database, I'm going to skip that. Tolerance. Remember, auto merge tolerance for joints. If you recall from the edit menu, there is merge joint, and like you could say, I'm going to ignore whatever below 1 millimeter in distance, right? So it tells you value cannot be 0 or negative. But we can do a little trick here. You can go onto tolerance, and you can call it 0.00, let's say 0.01. So it's 10,000th part of a millimeter, which is nothing, technically. And it's not going to give you an error, right? It's kind of how they cheated in mathematics and created the limits and the Laplace theory. And they were like, well, 10 times negative 10 is technically a 0, but it's just so far away. So this is how they invented the whole thing, right? And then the maximum inclination for vertical columns is like the column is allowed to incline slightly with a vertical with 1 degree. You're just going to leave everything as it is, click on OK. Now, if you go again, click on tolerance, what it says, it's a 0. But if you can, you see the issue here, like it's going to go back to, where's the tolerance? You see it's 0 already because, as I said, 0.0001, it's already just approximated to 0. When you click on exit, it's going to tell you error, but you can evade this problem and you're good to go. Now, it's just ignore about arrange windows because it can screw up your view. Now, graphics preference. Remember when they had labels, if we can show something, like right here, and let's say I'm going to show the labels, and I'm just going to show labels for the slabs, right? I'm going to remove the extruded view so I can see. I'm going to turn off the local axes. So you see how tiny this is, and the further you zoom, it's like stubborn, so it's telling you, well, I'm going to be even tinier. You have to hover on it to see the label. However, we can do something like which is really good, and it's also going to help you with further projects. Go to option, go to graphics preferences, and onto here you can change the font, but we're going to leave it as Arial. I want to put this to 15, maximum graphic font. I'm going to put this, let's say, to 8. I'm going to click on OK. Now you see it's bigger, and the larger you want it, the more you can increase the number, which is technically all you're concerned about is this one, maximum graphic font. So yeah, and the quality is about how the lines and how the thickness of everything looks like and how many pixels. You don't really need the quality in software analysis program. You would need quality later on in something like the BIM software, or something like, not a BIM software, just because everything here is technically BIM software, but you need the quality in something as drawing softwares. Next thing with the option is going to go graphical colors. You have to display and output. For the display, you can remember the beams and columns were in blue, the braces and links as well. And the walls are in red, as you can see. Floors are in gray. We can change this to be, let's put it to green. Click OK and click OK. Now the walls are green and this is gray. You can just tweak it however you like it. It's a self-preference thingy, you know. Output is, remember when we had contours here showing the, on the bottom side, on the bottom ribbon, showing the maximum and the minimum loads on the slab. It just shows you the colors. You can change it however you like it, but the color scheme is kind of neat, and it goes from like hot to cold, you know, so it's good. Just if you want to change it, you can change it. I personally keep it this way. On to the second thing is graphics mode, right? So this one is grayed out, by the way, architectural plan, because we don't have architectural plan just yet. When we get that, we're going to go through it. And then graphics mode is, you have two options: DirectX, which utilizes the graphics card that you have, if you have a graphics card, and then standard graphics, which technically uses utilizes the processor for doing the rendering. And if you can see, when I'm on standard and I'm like panning around, it does this. It's kind of rough, and it has to change the view. However, if you go to DirectX, you can see it's smoother, and it doesn't have to render each time you are panning around or rotating. And which one to use? You can see here video cards information. So if it's telling you it's compatible, yes it is, and this Microsoft render driver, just ignore the driver, you can update that, but both of the processor and the graphics card are compatible. If yours are not, it's going to make it easier for you to use the standard graphics. If you have a good one, you can use DirectX, so it's just it's not a critical thing, you know. Now, we're going to allow multiple towers, or technically how many buildings you have on the same grid. Now, show a start page at the startup. Remember the start page, if we can go back, a file, we're going to close this. Let's say I don't want to save it, and let's go here. This is our start page. If you disable that from the option, it's not going to show you the start page when you start up. And let's go back to our model. Now onto options again, it shows you show values at cursor for design. Keep that checked, it's really useful. And then show frame information in local plane, just keep that checked as well. Now show bounding planes, just ignore this for now. And architectural dimensions, the ones that we were drawing, onto here. Where is it? Yeah, there it is, dimension lines. Now again, moment diagram on the tension side. Well, this is because in some countries, well, regarding us, or regarding Egypt, you draw the bending moment, that's too thick, my bad. You draw the bending moment diagram on the tension side. So if you have a load like this, it's a point load, P, the bending moment diagram is going to be like this, PL/4, and this is the tension side. So that's why you put the rebar in the bottom side, and the top side is going to be the minimum rebar for the hangers. However, in some other countries, the tension side is actually on top. So if you have a load like this, or you draw, it's not the tension side on top, it's that you draw the bending moment diagram into the compression side. So if this is your P, and instead of doing this triangle down there, you're going to make it upwards. So this triangle is the bending moment, right? This is the bending moment diagram, and you're going to put your rebar in the opposite direction of the diagram. So this is just a quick feature in the options, just like this, which is draw the moment on tension side. That's on by default. If it's not, you're going to just toggle it to be off. As you can see here, it's off, so it's going to draw the bending moment diagram on the compression side. Animation sound is when you run your model and then you have something called start animation to see how the, if in case of seismic or something, how the structure is going to move. It plays some kind of animation. You can turn it off, you can turn it on, whatever you like to, right? And then auto-save the model. Now this is a really good feature. Let's say for whatever reason your laptop died, it crashed, the software crashed and had to terminate. Once you start, set the autosave model at specific interval, and let's say I'm going to autosave every 5 minutes. And when I'm working, it's going to show me a dialog, like a message, tell me 5 minutes, how fast do you want to save? You can save or you can cancel, and so forth. So just in case, assuming the worst, if something happened, then you just wasted 5 minutes, so it's not a big deal. Now go to options again, and save user default settings. Now what I was talking about is every time you start a new project, you would have to go define material, define your steel, and so forth. What you can do is, once you're done defining it once, go to options, save user default settings, right? And it's going to be saved successfully. So let's say I'm going to just go quickly to define, let's say I'm just going to define concrete. I'm going to say C30, or C30. I'm going to say this is 25, and this is almost 2100, and like something like that. Or we can just use the formula, which is 4400 multiplied by 30, power 0.5, so it's 2400. I'll leave everything as it is, adjust this to be 24, and you can call this C30 as well. Click OK, and click OK. And click OK. Now we go to options if we save the default settings. Okay, now we go to file, we go to new model. I'm going to say, let's say no for now. And I want to use the user default settings, right? I'm going to click on OK, and then I'm going to click on OK as well. And then when I go to define material, look at that. This is my C30, right? This is what I just finished defining a couple seconds ago. So that was, I don't want to save this anymore. That was the user default settings. It's really helpful if you're working with like typical projects or using just a slight difference in materials, so you don't have to go into defining a whole bunch of stuff every single time. And then reset user default settings is going to technically delete everything that I did. So if I did that, it was reset successfully. So if I start a new model, I will have the 4000 PSI kind of concrete, not the C30 that I was defining. Now these two, usually when you start your, if I click on reset, when you start your, you're going to see draw, select, and snap. But that's what you're going to have usually when you start the ETABS, right? You're not going to have the rest of the ribbons. What I like to do is have everything in front of me. So I'm going to go to options, customize the toolbar, and I'm going to put everything in there. So you see I have everything. I don't have to go to the edit menu, right? Let's just, you can click, you see here there is a little kind of a teal color kind of edge. You can hold and drag to change the position of the ribbon. So this is like the define material, right? If I click on this, I'm defining the material. I don't have to go to define, I don't have to click on this. With the draw, this is the draw menu. This is the snap option. This is the selection menu, a little bit of it, not all of it, of course, and so forth. So it's a really cool tip. If you want to reset everything, just click on reset. It's going to bring you back to whatever you were. But I like to keep it. These are not like show model explorer. If you don't want to, if you're not really using this and you think it's bothering you for whatever reason, click on option, hide the model explorer, and then you can see that the aspect ratio of my project has kind of it's kind of acting up. So what you want to do is click on these goggles, right? And it's going to fix everything for you. So now everything is proportional again. And I'm going to bring back my model explorer. See, and just click on these glasses looking thing as well, and click on it once more. There you go. It fixed it for you. So this was the options menu for now. Last but not least are tools and help. For tools, you probably only have the add and show plugins. Plugins are technically a third-party kind of software or a third-party extension that helps you facilitate something. So that's if you're a developer or if you know a plugin somehow that, let's say, gives you the shop drawing of the rebar, or snaps everything into place, or highlights the loosened parts from the project. It's gonna be, you're gonna add it or show it from here. I don't have any plugins recently, so yeah. Now with the help, this is really helpful. And the most helpful thing is documentation. Now what the documentation is, you're getting technically a user manual of everything, steel frame design, according to the different codes, right? And you can have tutorials, manuals, etc. So if you're stuck with something, just give it a quick look, and you might find it here, and it will take you to the PDF from the CSI, and it's explaining something regarding the topic you chose according to the code of the country you chose. Now again, you can see watch and learn, ETABS news, CSI on the web, and check for updates and about the ETABS. And technically, we are done. Just like a couple of few things right here. If, let's say for some reason, you want to toggle the extruded view, and it's not working. Sometimes, if we're just gonna go, let's say I'm gonna display, I'm gonna load the size, I'm gonna go frames, I'm gonna go to live, whatever. It's just like, let's say we're gonna change this into plank, for some reason, right? And I click on extrude view, and it shouldn't be working. Anyways, if it's not working, if you click on it and it refreshes the screen and it's not working, all you have to do is click on show undeformed shape, and then click on extrude, and it's gonna work out for you. So this was everything. I know this was quite a long of introductory video, but this is just to get you to know all the commands, not all the commands, but most of the commands and most of the stuff you're going to use to help us with the future projects. Thank you for watching, and I hope you have a wonderful day ahead.